Imagine standing at the edge of the ocean, gazing out across calm, turquoise waters, when suddenly, beneath the surface, the color deepens to an inky blue, as if the sea itself has opened its eye and is staring back at you. That eye, silent and ancient, is what scientists call a blue hole, one of the ocean's most mysterious features. These are not ordinary underwater depressions. They are vast marine sinkholes, vertical shafts that plunge into the Earth's crust through carbonate bedrock, sometimes extending hundreds of meters deep, beyond the reach of sunlight, beyond the comfort of familiarity. To the untrained eye, it might seem like just a darker patch in the sea, but to those who've dared to explore them, blue holes are something else entirely. Portals to a world where time seems to have slowed, perhaps even stopped. You can find these enigmatic formations scattered across the globe, tucked away in the Bahamas, in the still waters of the South China Sea, off the coast of Belize, and in a few other remote corners of the world where the sea has had time to carve secrets into the stone. Each blue hole is unique in its shape, depth, and chemistry. Yet all of them seem to carry a kind of silent gravity that draws scientists, divers, and dreamers into their depths. Some descend like chimneys, narrow and unforgiving, while others open into cavernous underwater halls, untouched and undisturbed for tens of thousands of years. What lies within them is not always easy to reach, and not everything that enters comes back up unchanged. What makes these blue holes so captivating to researchers is not just their shape or their eerie beauty, but the silence they've kept for millennia. Their waters are layered like a forgotten book, each stratum telling a story from a different time, sealed off from the winds, the waves, and the world above. They are among the most isolated environments on Earth, largely cut off from ocean currents and atmospheric exchange. Some contain water so deprived of oxygen that life as we know it cannot survive in the deeper layers. Yet even there, scientists have found strange organisms clinging to existence. These creatures have evolved in complete darkness, in waters laced with hydrogen sulfide and other toxic compounds. The chemistry down there is unlike anything we typically associate with life on Earth. It's a chemical brew more reminiscent of early Earth or perhaps of somewhere far beyond it. Blue holes are time capsules in the truest sense. Their walls contain fossils that date back tens of thousands of years, remnants of creatures that once walked the Earth before sea levels rose and buried their world beneath the waves. Some blue holes have preserved layers of sediment from before the last ice age, allowing scientists to peer into climates and ecosystems long vanished. In a way, entering a blue hole is like stepping into a memory the planet has buried deep beneath its skin. A memory too old to speak in words, but one that whispers its truths through stone and water. And so, as we begin this journey into the unknown, there are questions we ought to carry with us. Questions that don't have easy answers, but might shift the way we see our world. What kind of life forms have managed to survive in such hostile, lightless waters? Could these life forms resemble those we might one day find on other worlds, where sunlight never reaches and chemistry takes on alien forms? What can the preserved sediments and fossils tell us about Earth's ancient past, and what warnings or revelations might they hold for our future? Is it possible that blue holes, so isolated and so forgotten, are hiding secrets we aren't yet prepared to understand? There is something deeply human about our need to descend into the unknown, to shine a light where none has ever been cast, to reach into the Earth's hidden places and come back with stories. Blue holes invite us to do just that. They tempt us with their silence, their darkness, and the promise that what lies beneath might change how we think about life, time, and the strange, fragile balance that holds it all together. Part 1. The Life Inside. Once you've begun to grasp just how cut off these blue holes truly are, how still their waters remain, how untouched their depths have stayed through the passage of time, you start to realize that anything surviving in there must have learned to live by rules very different from those that govern life at the surface. Very different from those that govern life at the surface. There are no sunbeams reaching down to spark photosynthesis, no oxygen-rich currents flowing in to feed the breath of ordinary creatures. And yet, despite that absence, life persists. It doesn't shout, and it doesn't shine. But deep within these submerged chasms, microbes have found a way to endure, as if they've made a pact with the darkness itself. These microbes are extremophiles in the purest sense, organisms not merely tolerating extreme conditions, but depending on them. They thrive where almost nothing else can, in dense layers of toxic chemicals like hydrogen sulfide and ammonia, under pressures that would crush a human lung, and temperatures that fluctuate in ways few ecosystems ever experience. And in the utter absence of sunlight, they have built a life around chemistry. Instead of drawing energy from the sun like plants do, many of them use chemosynthesis, a process where life is fed by chemical reactions, pulling energy from compounds like sulfur or iron dissolved in the water. It's a quiet, deliberate process, far slower than the frenzy of light-driven life above, but in its own way, it is no less elegant. Some of these microorganisms form mats, fine, fragile layers that coat the stone walls or drift at the boundaries between different water layers. Others exist as isolated cells, barely visible, carried by slow-moving currents through their chemical labyrinth. They are remarkably specialized, having adapted to exact layers of salinity, pH, and chemical makeup. A shift too far in one direction, and they perish. But within that narrow band, they flourish, creating communities unlike anything seen in more familiar waters. Some of them even produce their own toxic environments. By processing sulfur, for example, they can generate even more hydrogen sulfide, making their home ever more inhospitable to others, and yet perfectly tailored to themselves. It's a kind of biological exclusivity, a self-made fortress in the dark. And what's striking is not just the resilience of these organisms, but what it reveals about the nature of life itself. These are not accident survivors clinging to the last scraps of habitability. They are refined products of evolution, fine-tuned by time and necessity to live precisely here and nowhere else. Their survival is not desperation, it's mastery. And when scientists lower their instruments into those still, dark waters and retrieve samples from these unseen microbes, they are not just collecting data. They are holding in their hands something profound, living proof that life can exist without the things we always assumed it needed. No sunlight, no oxygen. Just the quiet, chemical heartbeat of existence in the dark. To study them is to reckon with an unsettling kind of humility. Because if life can thrive here, at the edge of what we even consider life-supporting, it means we've barely begun to understand the boundaries of biology. And that makes every drop of water from a blue hole feel like more than just a sample. It feels like a message in a bottle, sealed by time, waiting for us to listen. And once you understand that these microbes aren't just surviving, but have carved out entire lives in a place that seems almost purpose-built to end life, you begin to wonder what kind of adaptations let them do it. Because hydrogen sulfide, for all its usefulness in their chemical dance, is a deadly gas to most living things. It suffocates by binding to the same places in cells that oxygen normally would, halting the processes that keep most organisms alive. And yet, down in these shadowy waters, there are creatures that don't just tolerate it. They depend on it. It becomes clearer then that the forms of life that call these places home have rewritten the rules for how life can operate, not by resisting their environment, but by becoming part of it. Some microbes have adapted with biochemical tools that let them break down hydrogen sulfide without poisoning themselves in the process. They wield specialized enzymes that can take this toxic compound and carefully extract its energy, just enough to power their own needs, without letting the poison linger long enough to do harm. Others have altered their very cell membranes, reshaping their structure to keep harmful ions out, or to manage pH levels that would strip the proteins from less adapted forms of life. Their internal machinery is precise, fine-tuned across generations, not to reject the environment around them, but to draw strength from it, like learning to breathe underwater in a sea of gas. And it's not just the chemicals. They've also adapted to the absence of oxygen in ways that seem almost counterintuitive to how we think of life. In anoxic zones, where not a trace of oxygen lingers, these organisms rely on electron acceptors that most of us wouldn't even think of as useful. Things like nitrate or sulfate instead of the usual oxygen. And some of them take it even further, forming partnerships with other organisms in quiet cooperation. One microbe might produce sulfur as waste, while another lives off that very compound, creating cycles of dependency that allow entire communities to survive in balance, right on the knife edge of toxicity. There's something undeniably human about the idea of life bending instead of breaking, of finding a way not in spite of the darkness, but because of it. These adaptations didn't happen all at once, and they didn't happen with a goal in mind. But over time, piece by piece, they accumulated, until the impossible became not just possible, but normal. When scientists study these adaptations, they're not just peering through microscopes. They're watching the story of survival unfold in its most distilled form. A story not of strength or dominance, but of quiet precision, of fitting into a world that offers no comfort, only the raw edge of necessity. And maybe what strikes us most, as we look deeper into these blue hole organisms, is the sheer persistence written into their biology. It's not dramatic, it's not loud, it's just enduring. That kind of quiet resilience, that ability to shape oneself into something the world didn't expect, there's a kind of grace in it, and maybe even something familiar. Because we, too, in our own way, are always adapting, always trying to find our breath when the air gets thin. Down there, beneath all that still water, life has simply been doing it a little longer. And as you follow that trail of survival deeper into the heart of these submerged worlds, another truth begins to rise. Not in a sudden realization, but like the slow unfurling of something ancient and deliberate. The water itself is not one single realm, not one continuous space where life drifts freely from one end to the other. It's layered, like the rings inside a tree trunk or the pages of a forgotten book, each level holding its own story, its own chemistry, its own form of life, sealed off from the others by invisible barriers that seem to whisper, "This far, and no farther." The strangest thing about these layers is how still they are. You might expect the currents to stir things up, to swirl the water like cream into coffee. But here, that never happens. The layers remain separate, divided by shifts in salinity, in temperature, in chemical makeup. A warm upper layer may lie above a cold, dense pocket filled with hydrogen sulfide. A thin, sharp line might mark where oxygen ends and suffocating anoxia begins. These lines are not vague, not gradual. They're precise, often measured in centimeters, and to cross one is to enter a completely different world. Creatures that belong to one layer do not stray into the next. They remain where the conditions match what they've spent generations adapting to. It's not a choice. It's necessity, etched into the very core of how they live. To stand at the edge of one of these layers, or to watch it through the eye of an instrument lowered into the deep, is to see something hauntingly familiar in a way you might not expect. Because we, too, live in layers. Not of water and sulfur, but of society, of thought, of experience. We build boundaries, sometimes visible, sometimes not. And each layer holds people who breathe different air, who learn to move within the pressure of their own world, rarely crossing into another. In blue holes, this layering isn't abstract. It's physical, it's real, and it governs everything that happens. What lives above can't survive below, and what thrives in the dark doesn't belong in the light. What's most unsettling, though, is the quiet permanence of these divisions. There's no turbulence to shake the layers, no tides to blur the lines. They remain fixed, stable, untouched even after centuries. And so the ecosystems within them evolve separately, as if they are entirely disconnected planets floating one atop the other, each with its own rules and rhythms. A microbe in one layer may never even know the kind of life that lies just meters below. And that sense, that feeling of vertical isolation, leaves you with a kind of reverence. Because it's not chaos that reigns in these depths. It's order. Not the kind we impose, but something older, more patient. Something that watches without ever needing to change. And as you rise back toward the surface, where sunlight finally pierces through the water, you carry with you the quiet knowledge that even in the most alien places on Earth, life isn't scattered randomly. It's arranged with purpose. Each form of it finding its place, staying in its place, adapting in silence to the narrow band of reality it's been given. And in that stillness, there's something that reminds us, not of how different we are, but of how much we still have to learn about the ways life can divide itself, survive apart, and yet remain connected in the deep. And when you begin to grasp the stillness of those layers, the way each one holds its breath in separation from the rest, you start to notice what lies quietly at the seams. Those fine edges where life doesn't just endure, but shapes the very foundation of the ecosystem itself. Microbial mats. At first glance, they don't look like much, just faint, fuzzy coatings across the sediment, or delicate layers stretched along the boundary between water and rock. but their presence speaks of a story far older than any one creature, a story told in cycles, not in moments. These mats aren't loose gatherings of random microbes. They're structured communities, living fabrics made up of layer upon layer of tiny organisms, each one performing its own role, passing off byproducts to neighbors like breath passed between generations. Some live on sulfur, others on carbon dioxide or methane, some needing only the faintest light, while others flourish in complete darkness. And together, they form a kind of choreography that doesn't change with seasons, or tides, or even the passing of centuries. In the protected hollows of blue holes, where external disturbances are rare, these mats become timekeepers. Some have persisted in the same spot for thousands of years, maintaining the same metabolic patterns while the world above them has shifted and reshaped itself over and over again. Their strength lies in diversity, not just in species, but in chemical strategies. One layer might oxidize sulfur, the next might fix nitrogen, and another might break down ancient organic compounds buried deep in the sediment. They are, in a sense, the lungs, the stomach, and the waste system of the blue hole's internal world, keeping balance in a place where balance seems impossible. And though they are microscopic, they shape the entire structure of life in those depths. Without them, the fine line between survivable and lethal would collapse. These mats absorb what would otherwise poison, store what would otherwise disappear, and recycle energy in a closed loop where very little is ever wasted. There's something undeniably human about this quiet, enduring cooperation. We too build our lives in layered systems, in communities that depend not on individual brilliance but on connection, on stability, on the quiet passing of knowledge and function from one to the next. These microbial mats, in their own way, are ancient neighborhoods, complex, interwoven, and surprisingly elegant. They show us that resilience doesn't always come from change. Sometimes, it comes from continuity, from finding a system that works and holding it in place, not just for a lifetime, but for millennia. And in their silence, they remind us that life doesn't need to be grand to be astonishing. It only needs to endure, to adapt, and to persist with quiet purpose across the deep, unmoving years. Imagine drifting slowly down into the mouth of a yawning blue hole, that deep azure throat in the middle of the ocean, still and silent like a forgotten entrance to another world. The light fades, filtered and dissolved in gradients until even your hands are ghosts in front of you. With every meter, you're descending not just into pressure and cold, but into time itself, into an environment untouched by sunlight, wind, or even the seasonal rhythm that governs the rest of the sea. And in that alien silence, something lives. Now, think of a person, maybe a diver or a marine biologist, spending years of their life drawn to these underwater voids, not because they're pretty, but because of a feeling they can't quite explain. That sense, deep in the chest, that what lies below could rewrite the rules, not just of marine biology or geology, but of what it means to be alive. Because in those depths, beyond the reach of casual observation or even conventional exploration, may exist entire microbial civilizations we've never seen. Not just rare bacteria, but entire branches of life, thriving in toxic gases, digesting sulfur and methane, communicating in chemical whispers. It humbles a person, knowing that even in the age of satellites and algorithms, there are entire ecosystems that might have never once interacted with the life we know. They don't need oxygen the way we do. They don't answer to sunlight. Some may have evolved along entirely different paths since Earth was young and molten. They persist in layers of hydrogen sulfide so thick, so poisonous, it would peel the lungs of any human who dared breathe it. But to them, that isn't poison. That's air. That's home. A scientist who samples that water, cupping the silt between their gloved hands, knows that they're holding a kind of biological time capsule. Inside those particles could be microbes that haven't changed in 1 billion years. Or perhaps they've evolved into something stranger, something we've never imagined. The way their DNA folds, the way they divide, the way they process memory or sense the environment, it may not fit into our textbooks. And that's both terrifying and exhilarating. Because what if one of them carries a molecule that could cure a disease we don't even have a name for yet? Or a structure that rewrites what we thought proteins could do? You see, it's not just about novelty. It's about reverence. that someone could dedicate their entire life to studying life and still find themselves surprised in the presence of something so old, so hidden. It feels like the Earth kept a secret just for them. The deeper they go, the less it feels like they're observing life, and the more it feels like life is observing them. Unfazed, unbothered, and utterly indifferent. That's the great paradox of blue holes. In the stillness, in the ancient toxicity, in the black silence where no birds sing and no trees grow, life flourishes. Not in our image, but in its own. And if that doesn't humble you, nothing will. And as we sit with the unsettling thought that entire unseen communities may exist beneath us, unmeasured, unrecorded, there's something else, something quieter, that waits in those same depths. Not life exactly, but what remains after life has ended. Down in the belly of a blue hole, where the water turns dense with chemicals and the oxygen thins to near nothing, the rules of death change just as much as the rules of life. What dies down there doesn't decay like it does in the world above. It lingers. It waits. It resists the pull of time. Now imagine a person, maybe a researcher retrieving a corroded sampling tube, or a diver brushing past something that shouldn't feel solid anymore, but does. The moment their hand touches it, there's that instinctive recoil, not out of fear, but from the realization that this thing, this remnant of something once alive, has not returned to the earth like it should have. In any other place, bacteria would have claimed it by now. Insects would have played their role, air would have encouraged the breakdown of tissue, and the cycle of life would have moved on. But here, in the oxygen-starved silence of the hole, there are no such actors on the stage. The cast is limited. The pace is glacial. You see, decomposition is more than just rot. It's a symphony of tiny lives feeding on what once was, competing with one another. Each microbe taking its turn in a cascade of hunger and transformation. But that competition, that frenzy of microscopic consumption, needs air, needs oxygen to fuel the fire. Without it, those microbes that would normally race to consume and replace are either too few or altogether absent. And without them, death doesn't feel like an ending. It feels like a pause. Bodies, of animals, of plants, of smaller things too, sink and lie almost untouched. Their outlines remain. Their softness hardens. What should vanish into the water's memory remains etched in its silence. And it has an effect on the people who witness it. There's something eerie in seeing a thing that should have returned to the elements years ago, still waiting. It's not preserved in the way we think of mummies or fossils. It's softer than that, less deliberate. It's as if time, down there, simply forgot to move forward. For the living, it's a quiet lesson in humility, because in a world that's always rushing to grow, to consume, to end and begin again, there's something strange and deeply moving about a place where even decay must wait its turn. And in those slow, patient depths, you begin to wonder whether the earth remembers more than it forgets. And once you've stood in the stillness of that forgotten time, watched how the dead remain intact, how silence becomes its own kind of gravity, it becomes harder to dismiss the whispers that echo out of those depths. Not the kind spoken aloud, but the ones you hear in your bones. Because in those blackened chambers, where even decay refuses to follow the script, some scientists allow themselves a dangerous thing. They wonder. These are not the sort of guesses you put in bold letters or announce at conferences with confident voices. These are the hushed after-hours thoughts. The ones that stir late at night when a researcher's alone in the lab, going over readings that don't quite make sense, patterns that shouldn't be there, sonar echoes that return with shapes too large, too deliberate, to belong to drifting silt or harmless debris. In those moments, speculation blooms. Speculation. What if, nestled within that dense water column, there is more than bacteria, more than filter feeders and blind eels? What if something larger, something that defies not just expectations but classification, exists there in quiet defiance? The truth is, blue holes are not just vertical tunnels into the seafloor. Some of them branch out, stretch sideways like veins, forming vast underwater chambers and corridors that have never felt the touch of human eyes. And within those places, evolution might have carved something strange. Not monstrous, not cinematic, but simply unfamiliar. Something that learned long ago to thrive in the absence of light, to sense movement without sound, to feed slowly, without chase or violence, something that never needed to surface, and so never did. Now imagine the person chasing that possibility, not with fantasies, but with quiet persistence. They load instruments into fragile submersibles. They listen for disruptions in the water column, anomalies in chemical readings. They return with nothing again and again, but they keep returning. Because they've seen just enough to suspect. And sometimes that's all it takes. One brief signal. One moment of static that wasn't static at all. It's not about proof. Not yet. It's about patience. About respecting the scale of time and the limits of our own presence in places we weren't built to reach. And in those rare moments, when science edges closer to myth, and myth flirts with data, it reminds us that Earth may still have corners that haven't finished speaking. We just haven't learned how to listen yet. Part 2. Their origins and structures. Long ago, when the world was locked in the cold embrace of the ice ages, the oceans lay much lower than they do today, retreating to expose the limestone bedrock beneath what we now know as the seafloor. In those ancient days, rainwater, slightly acidic from carbon dioxide absorbed in the atmosphere, began its quiet work, seeping into cracks and crevices, dissolving the stone little by little. Over centuries, even millennia, that gentle persistence carved vast caverns and winding passageways beneath the earth, sculpting hollows in the bedrock that only time and water could shape. These were the beginnings of what would one day become blue holes, though at the time, they were simply deep caves in the dry, sunlit ground. You can imagine people had they been standing on those prehistoric plains, walking unknowingly above these voids, these hidden chambers of silence, oblivious to the empty space just beneath their feet. Back then, the idea of a hole in the ocean wouldn't have made much sense, because the sea hadn't yet returned to reclaim the land. But the earth is always shifting, always changing, and as the glaciers melted and the seas crept back over the limestone plateaus, those caves were swallowed whole, flooded by rising tides. Their ceilings sometimes collapsed under the weight and pressure, opening up wide mouths that now gape like entrances to another world. What remained were vertical shafts descending into darkness, cold, still, and quiet. From the surface, they appear serene, like deep blue eyes staring up from the ocean floor. But their true story lies in the way they were formed, not by sudden violence, but by a slow unraveling. It's a kind of geological memory preserved in stone and salt water. These holes are remnants of a time when the world felt different, the air colder, the oceans farther away. They are monuments to patience and pressure. For the people who live near them now, divers, scientists, fishermen, they can feel like thresholds between eras, between the solid world we walk on and the one we can only drift through with breath held and lights strapped tight. And though we understand much about their formation today, standing at the edge of a blue hole can still stir something old in the human spirit, something that recognizes not just mystery, but the deep, slow rhythm of the earth beneath us. And as those caves filled and the world slowly warmed, the story didn't end with the ocean's return. It kept unfolding, deep below the surface where light begins to falter, and pressure tells its own truths. You see, the thing about limestone is that it doesn't stop changing just because it's hidden underwater. The same forces that once carved out hollows in dry ground continue their quiet work beneath the waves. Water, even now, moves through the stone, sometimes fresh, sometimes salt, sometimes mixed and brackish, carrying with it the power to dissolve, to erode, to unsettle what once seemed solid. Over time, that constant seepage weakens the ceilings of those ancient cavities, the old chambers formed in an air-filled world, and when the weight above becomes too much, it gives way. This collapse isn't sudden in the way a cliff might crumble in a storm. It happens on its own scale of time. Slow build, quiet shift, and then one day the roof falls. Tons of rock break loose and tumble down into the hollow beneath, leaving behind a vertical void where once there was pressure, weight, and silence. If you were there, floating in the stillness of a calm sea, you might not even hear it. But below, the seafloor has changed. What was once stable is now a hole, a pit descending into darkness, and that hole may only grow deeper with time. The sea swirls down into it, sediments shift, and life finds new ledges and crevices to cling to. For those who dive these places or study their movements, there's a tension you feel, not in danger, but in scale. You come face to face with the fact that the ground, even underwater, is not fixed. That stone, when coaxed gently over millennia, can fold and break and fall apart, and while the sea above may stay calm, still reflecting sunlight as though nothing stirs beneath, you know that somewhere down in the cold, slow quiet, the earth is breathing in its own way, patient, relentless, and never truly at rest. And when the ceiling does give way, what's left behind isn't just a simple hole. It's a shape carved by gravity, water, and time working in tandem, each leaving its own fingerprint on the stone. If you could stand at the edge and look straight down into one of these blue holes, you'd notice how often they taper near the surface, as if the earth were reluctant to reveal too much too quickly. That narrow entrance, like the neck of a bottle, leads into chambers far wider below, sometimes cavernous, sometimes layered like the inside of a cathedral built in slow motion. It's not random, this shape. It's the result of what collapses, what resists collapse, and how water chooses its path through stone that doesn't always welcome it. In the earliest stages, long before the ocean claimed these places, water moved sideways and downward, carving horizontal passageways just beneath the surface. But as those passages grew and ceilings began to strain, collapse would start from above, in small pieces at first, gradually creating a vertical shaft where once there had been only narrow cracks. The weight of everything above that weakened ceiling pressed down, and when it finally gave way, what fell didn't flatten everything evenly. It left edges and contours, pockets and drops, a narrowing here, a widening there. Over time, erosion smoothed some of it out, but the general shape remained, a slim throat leading into a deep chamber below. If you've ever walked into a room through a small doorway and found yourself suddenly in a space much larger than expected, you know that feeling. The sense that you've crossed into something more than just open air. That's what these bottle-shaped blue holes do to a diver or a researcher descending slowly through the neck. They make you aware of how geology shapes not just land or sea, but the way we experience space itself. You begin in confinement, in a tight corridor of rock and water, and then you break through into something vast and echoing, like you've fallen into the breath of the planet. And in that moment, you understand. This shape wasn't made for you, but it still holds you, cradles you in the remnants of collapse and chemistry, in a vertical history written by unseen hands. And once you've slipped through that narrow throat and found yourself suspended in the silence of that chamber, you begin to realize something else. These blue holes, for all their self-contained mystery, aren't always alone. Beneath the still water and ancient stone, some of them are joined to others, connected by hidden tunnels and submerged corridors that twist and run deep through the limestone. These aren't the kind of tunnels built with symmetry or intention. They're the accidental artistry of water, which, over countless ages, kept seeking paths of least resistance, carving out routes where none were meant to exist. To the untrained eye, it might seem like coincidence, a cave leading off to the side, a dark passage disappearing into the rock. But for those who know where and how to look, there are signs. Shifts in salinity, subtle movements in temperature, unexpected currents whispering through what should be still water. All of them hints that somewhere, a passage continues, and those who followed them, those few divers willing to crawl through flooded rock with only a line and a light to guide them, speak of spaces where one blue hole leads to another, sometimes miles apart, linked like silent, sunken cathedrals sharing a secret. There's something humbling in that. We like to think of land and sea in terms of boundaries, separate and knowable, but here, the rules change. Here, what appears isolated from above is part of a deeper network, a buried geography written in water and limestone. And for the people who explore these systems, not just with instruments, but with their own breath held tight, there's a sense of entering not just the earth, but a kind of memory, like finding a trail in a dream you didn't know you had. You start to understand that what lies beneath isn't just a hole, or even a cave, but a passage through time itself, twisting, submerged, and still unfinished. And as you follow those tunnels, those shadowed veins through the stone, you begin to see how not all sinkholes are born alike, though they share a common ancestor in the slow, dissolving touch of water on limestone. The marine blue holes out in the ocean are shaped by a unique story, a history that includes not just the carving out of caverns in a time when land was dry, but also the slow return of the sea and the strange chemistry it brings. Salt water, dense and heavy, fills these voids and often settles beneath fresher layers above, creating a stacked column of differing waters that rarely mix. This separation forms sharp boundaries, haloclines, chemoclines, where oxygen vanishes and ancient life, adapted to isolation, endures in stillness. In contrast, inland sinkholes and the cenotes of the Yucatan, though similar in shape and origin, remain connected more directly to the land and to the cycles of rainfall and runoff. The water there is clearer, often fresher, and replenished more freely by the movement of aquifers and the breath of open skies. Cenotes, especially, were once sacred to those who lived nearby, not just because of their beauty, but because they offered life in a place where water could be rare. You can walk to a cenote, see the light cut through the water, feel the breath of the earth rise cool from its depths. There is something intimate about them, something immediate. They're closer to the surface in every sense, geographically, chemically, spiritually. But the marine blue holes, they're another matter. Isolated by salt, pressure, and time, they often contain water that hasn't been disturbed in thousands of years. Some are anoxic below a certain depth, utterly lacking in oxygen, where microbial life clings on in sulfuric layers that drift like ghosts. You wouldn't drink this water or swim in it without caution. It's not part of your world in the way a cenote might be. It's something older, sealed away, and largely uninterested in human presence. And yet, when a diver lowers themselves into either one, whether surrounded by mangroves and birdsong or far offshore where only the wind speaks, that feeling of being suspended between two realms remains the same. It's the knowledge that beneath your feet lies not just water, but a story the planet has been writing long before we arrived to read it. Part 3. Windows into the past. Imagine, if you will, a place untouched by time, not in the poetic sense, but quite literally sealed away from the modern world. Deep beneath the surface of tropical seas, blue holes sit in silence, vast and still, like liquid entrances to another era. These aren't just underwater caves. They are chambers of history, protected by nature's most unyielding sentinels. Darkness, stillness, and a lack of oxygen. The air we breathe, the sun we chase, the chaos of tides and storms, none of it touches what lies beneath those yawning entrances. And that's exactly why blue holes have become some of the most remarkable time capsules on Earth. You see, down there, the water barely stirs. No strong currents to wash things away, no light to hasten decay, no oxygen to feed the bacteria that would otherwise feast on organic remains. It's cold, it's quiet, and it's chemically stable. And in such a place, time forgets to move forward. A leaf that drifted down from a tree thousands of years ago might still be resting where it landed. The bones of animals, and sometimes even humans, can lie preserved, almost as if they had just sunk in yesterday. Scientists descend into these waters knowing that what they're seeing isn't just history recorded in books or told through stories. It's history still resting in place, untouched. There's something haunting about the human connection to that. We build monuments and bury time capsules trying to leave behind some trace of our brief presence. But here, the Earth has been doing it on its own, without our help. The blue hole does not preserve out of sentiment. It preserves out of conditions so extreme, life itself hesitates. And yet, for researchers who risk the depths, it offers a kind of quiet generosity. The pollen of ancient plants still intact in the sediment layers, microscopic shells that speak of climates long gone, DNA from creatures that no longer exist, and sometimes, evidence of our own ancestors. To dive into a blue hole is not like entering a cave or wandering through a ruin. It's more like opening a door that was shut before our civilizations even began. And when a diver slowly drifts past those ancient layers, suspended between past and present, it isn't just about what they see. It's about the stillness they feel, the overwhelming awareness that below the surface, time decided to wait. Not for us, but it waited all the same. And once you're there, suspended in that silence where time gave up its chase, you begin to realize that the story isn't only in the bones or relics. It's in the sediment, layer upon layer, each one laid down like a page in a book, quietly recording what the world was like long before anyone was around to give it a name. These layers don't shout. They whisper, and you have to know how to listen. They hold the memory of Earth itself, trapped in fine grains of sand, silt, and ancient dust that drifted in and settled at the bottom when the world above was very different. And when scientists core into those layers, they're not just collecting dirt, they're holding a record of the planet's breath. You might not think mud could tell you anything meaningful, but deep in those compressed layers are chemical fingerprints, tiny bits of trapped air, specks of ash, fragments of once living things that carry stories of a sky filled with volcanic ash or an ocean that once rose up over land. There's something humbling in that, in knowing that a single millimeter of sediment can hold the weight of an entire generation of climate. A snapshot of a flood that swallowed forests, or the chill that crept across the world after a distant volcano darkened the sky. These are not the dramatic moments people remember, yet they shaped everything. Entire civilizations rose and fell, not realizing their fate was already buried beneath the sea in places like this. And what's more human than trying to understand where we come from, and what forces shaped the path we now walk? When researchers lower their instruments into those depths and retrieve a core of layered Earth, they're not just after data. They're reaching back across millennia, searching for the quiet decisions of nature. How much rain fell, how high the oceans swelled, how warm the winds blew. Because buried in that silence, below the reach of sunlight and storms, is the truth of how the planet has lived and changed. And that truth, like all good stories, is not written in the big events alone, but in the slow, patient passing of time. And just as those layers quietly record the breath and pulse of the Earth, every so often, they also cradle the remains of life itself. Fossils that once moved, fed and breathed under skies we'll never see again. These aren't the massive dinosaur bones that catch headlines or fill museum halls, but they're no less powerful. Fish with bones so delicate you can count the ribs. Shells from creatures that lived when sea levels were hundreds of feet lower or higher than today, and even the occasional remains of birds or mammals that met their end near the edge of a long-forgotten shoreline. Some are just fragments, teeth, bits of bone, but others are startlingly whole, their forms undisturbed, as if they simply fell asleep in a world that no longer exists. There's something profoundly human in the act of recognizing a shape, maybe a jawbone or a vertebra, and knowing it belonged to something that once lived out its days under a different sky. It reminds us that we're not the first to call this planet home. Some of the fossils found inside these blue holes are thousands of years old. Others stretch back tens of thousands, even reaching into the last ice age. In a few rare cases, the discoveries haven't just been animal. Some have found the remains of early humans, preserved with astonishing clarity, telling us about migration, survival, and perhaps even ritual. And when that happens, the line between past and present becomes impossibly thin. To hold something that lived so long ago, that died quietly and was never disturbed, it stirs something in people: curiosity, reverence, maybe even a kind of sorrow. Because for a moment, you're not just looking at a fossil. You're meeting a life. You're standing at the edge of a moment that would have otherwise been forgotten. Except the Earth, through some quiet miracle of chemistry and chance, chose to remember it. And in that deep blue silence, where no one was ever meant to go, that memory waited patiently to be seen again. And as you drift deeper into that ancient silence, past the fossils and through the layers that have captured the weight of forgotten worlds, you begin to find something stranger, something still alive. Not large or striking, not something that swims or stirs the water. Just a thin, wrinkled film clinging to the rocks and sediments, quietly pulsing with life. Microbial mats. To most, they look like nothing more than slime. But to those who understand, they are far more than that. They are echoes, living fragments, of the earliest chapters of life on Earth. These mats are not made up of one thing, but of communities. Microbes living together, layered like the sediments beneath them, each layer doing its part. Some absorb sunlight, others fix carbon. Others scavenge what little energy they can from the elements around them. They thrive in the low-oxygen, low-light environments of blue holes, places so extreme that most of modern life can't even survive there. But these mats flourish in those conditions because they come from a time when the Earth itself was alien, before trees, before fish, before anything had taken a true breath of oxygen. It's a humbling thing, watching something so simple, yet so ancient, carry on as if the last few billion years never happened. These mats mirror the microbial ecosystems that once ruled the planet, long before complex organisms came into the picture. In a way, they're not just survivors. They're reminders of what came first. For scientists, studying them is like stepping into a time machine. They offer clues to how life began, how it learned to harness energy, how it built the chemical foundations for everything that came after, including us. And perhaps what makes them most profound is not just that they endure, but that they've been doing the same thing for longer than anything else on Earth. No bones, no teeth, no eyes. Just layers of cooperation, held together by necessity and time. To find them in the deep places of the world is to come face to face with our origin, not in a grand or theatrical sense, but in a quiet, persistent one. The kind that doesn't need attention to matter. The kind that waits, unnoticed, until someone finally chooses to look closer. And when they do, they're not just studying biology, they're listening to a voice from a time when Earth was young and life was just beginning to whisper its first words. And when you finally begin to understand that even the simplest forms of life can carry the weight of the world's earliest moments, the question naturally turns to something even deeper. What's left behind in the smallest traces, the invisible remains? Because even after bones vanish, even after microbes go still, something lingers. DNA. Fragments of ancient code, buried in the quietest corners of deep sediments, holding the record of life long since vanished. It's not the kind of evidence you can see with your eyes, not something you can hold in your hand, but it carries the truth in ways no fossil ever could. In those layers, buried beneath centuries of stillness, strands of genetic material and broken down biomolecules endure against all odds. They don't survive in perfect condition. Time wears them down, piece by piece, but even in fragments, they whisper stories. Stories of what once lived in the water, in the mud, on the shores. Algae, bacteria, tiny animals. Things with no shells, no skeletons, no way to leave behind a traditional trace. But their DNA remains, trapped in place like messages folded into the earth, waiting for the right moment and the right eyes to be seen again. And when those sequences are carefully drawn out, sequenced in quiet labs far from the sea, something remarkable happens. A picture begins to form, not just of what lived, but of how those lives responded to the world around them. That's the part that touches something deeper in us. Because what this material reveals isn't just lists of species or names in Latin. It reveals change, how organisms adapted to warmer or colder waters, how salinity shifted, how nutrients flowed or vanished, how communities of life rebuilt themselves again and again. These traces don't just show what life was, they show how life responded. And that strikes a chord with any of us who've ever wondered where we're heading, and whether we're listening to the lessons already written into the past. So when scientists extract these delicate remnants from the depths, it's not about curiosity alone. It's about memory, biological memory. The kind that doesn't live in stories or books, but in the code of things that once lived and died in places the sun never reached. And through that memory we get something rare, not just a view into what the Earth once was, but a reflection of how fragile and resilient life can be. A quiet reminder, buried deep in ancient mud, that the story of Earth is written not only in stone, but in the soft, fading ink of life itself. Part 4. Toxic chemistry. Imagine drifting down into the stillness of a blue hole, the sunlight fading with every meter, the world above slipping quietly into memory. At first, it's like any other deep part of the ocean, cool, silent, and just faintly eerie. But then, something changes. The water becomes murky, darker than it should be, and there's a faint, almost metallic sting in the nose if you were to breathe. Though down here, that's a dangerous thought. This place isn't just deep, it's layered. And hidden in those layers is a strange and toxic boundary that feels like a border between two worlds. That's hydrogen sulfide, thick and unforgiving, suspended like a fog in the water. It doesn't swirl around or mix freely like you might expect. It just sits there. A sharp line between life as we know it and something far older, far more alien. This strange chemical division exists because the water in a blue hole doesn't move the way it does in the open sea. There are no strong waves, no mixing currents, no tides crashing against rock. It's a quiet prison of water. The surface layers, the ones touched by wind and weather, hold oxygen. They support familiar life, fish darting about, microbes doing their invisible work. But deeper down, where light doesn't reach and oxygen struggles to penetrate, life takes on a different shape. Bacteria thrive here, ancient and efficient, breaking down organic matter that sinks from above. As they digest, they release hydrogen sulfide, a gas that's not just foul-smelling on land, but deadly in high concentrations down here. It accumulates slowly over time, fed by the remains of creatures who've wandered too far, and by the endless cycle of death that gravity always pulls downward. But here's the strange part. You'd think this toxic gas would simply rise up and mix with the water above. That's what we're used to, a world where things blend and balance. But in the blue hole, everything is still. There's no real mixing, because the density difference between oxygen-rich water and sulfide-laced water creates a natural barrier. The two layers settle into a fragile truce, heavier water below and lighter water above, neither willing to trade places. And that boundary, sharp as a blade, stable for centuries, keeps the ecosystem frozen in its own kind of time. It's so well defined that if you were diving down, you'd actually see it as a visible layer, like the water itself is bruised or fogged. Go just a bit deeper, and it's like falling into another planet's ocean. To a diver, it might be beautiful in a terrible sort of way. You're aware of your fragility here, of how much you don't belong in this hidden realm. One mistake, one breath in the wrong place, and you'd be overwhelmed by a gas that chokes life away in seconds. But for the bacteria living there, this is home. They've been perfecting survival in this hostile place long before we even learned how to stand upright. Their world is toxic to us, but balanced for them, perfectly suited to an ecosystem that depends not on oxygen, but on chemical reactions that seem almost alchemical by human standards. So that's how it stays, quiet, divided, balanced not by peace, but by chemistry. And while we look down and try to understand it with our instruments and our curiosity, the blue hole doesn't care. It simply is, untouched, undisturbed, and unwilling to change. And so, once you cross that invisible threshold into the deeper part of the blue hole, into the heavy, stifling layer just below the light and the oxygen, what you encounter isn't just an absence of breath, but the presence of something far more insidious. Hydrogen sulfide. It isn't just another gas. It's a molecular ambush wrapped in something deceptively simple. Just two atoms of hydrogen bound to a single atom of sulfur. On paper, it seems harmless, even forgettable. But the way it moves through the body, the way it shuts down the very machinery of life in seconds, tells you just how deceptive nature can be. And if you were there, floating in that layer, it wouldn't take long before your cells started slipping quietly out of function, like lights flickering in an old hallway. Hydrogen sulfide, at its core, interferes with how life makes energy. Not in a dramatic, explosive way, but in a quiet sabotage that begins deep inside your cells. Every breath we take brings in oxygen, and our cells use that oxygen to make energy through a chain of delicate, precise reactions. But when hydrogen sulfide enters the scene, it binds to the enzymes that keep that chain alive, clogging the system like sand in a clock. Suddenly, your cells can't use the oxygen that's already there. Your lungs might be full, your blood might be carrying oxygen just fine, but at the microscopic level, where life truly unfolds, everything stops. It's as if someone cut the power to an entire city without warning. And for humans, the danger isn't theoretical. We're finely tuned to avoid this gas because it has betrayed us too many times before. At low levels, it smells like rotten eggs, a foul warning that something is wrong. But climb just a little higher, and even that signal disappears. Hydrogen sulfide dulls your sense of smell as it becomes more concentrated. That's the cruel trick of it. The very system meant to alert you goes quiet, and from there, you're blind to the danger. Breathe too much of it, and the effects come quickly. Dizziness, confusion, collapse. The heart might keep beating for a while, the brain might struggle to stay alert, but the cells underneath are already gone. They're starving, not for food, but for the chance to use the oxygen they have. And yet, in that same toxic space, other life forms flourish. Because what kills us is just another pathway for them. They don't rely on oxygen the way we do. They've evolved in a world we would never survive, using hydrogen sulfide the way a campfire uses fuel. It's a reminder that our definition of what life needs is narrow, shaped by our experience, not by the universe. And in that contrast, between our vulnerability and their endurance, there's something humbling. You begin to see life not as a single story, but as a collection of adaptations, each one shaped by the chemistry of its surroundings. Hydrogen sulfide doesn't hate us. It doesn't have to. It simply exists, doing what it does, without intent or malice. It's our biology that loses the battle, and in places like the blue hole, where this gas gathers in silent layers and lingers through the centuries, we are only visitors, brief and fragile, passing through a world that's never really been ours. That quiet separation between life and toxicity, between oxygen and suffocation, doesn't just hold because of chemistry alone. It holds because the water itself refuses to stir. It's a kind of stillness most of us never think about, because we live in a world shaped by movement. We walk through air that churns and shifts with the weather, drink from rivers that race and tumble, and swim in seas that pulse with tides. But in a place like a blue hole, the water settles into layers that behave more like glass than ocean. This is chemical stratification, a subtle but powerful layering, built not on color or temperature alone, but on weight, density, and time. And once these layers form, they can stay in place for years, even centuries, without ever blending. Water, as simple as it seems, is sensitive to what it carries. Dissolve a little salt, change the temperature, or add something heavier like hydrogen sulfide, and suddenly it behaves differently. The molecules cluster more tightly, grow heavier, and sink just enough to form their own invisible floor. Above that, lighter water stays in place, floating not because it's trying to, but because gravity insists it does. And just like oil doesn't mix with water, denser anoxic water stays where it is, held down not by pressure from above, but by its own nature. There's no storm inside a blue hole, no cold current strong enough to flip the system upside down. Everything remains still because the forces that would usually stir the ocean, wind, waves, tides, can't reach this far into the Earth's mouth. Imagine a glass of layered liquids. Syrup at the bottom, oil at the top, water in between. Shake it, and it blends. But leave it untouched, and it separates again, slowly and completely. Now imagine that, not in a cup, but in a vast ancient chamber of the sea. That's what you're looking at, and as a human being peering down into those layers, you feel how alien it is. We come from a world where change is constant, where a gust of wind or a sudden wave can alter a coastline. But down here, there's a kind of stubborn resistance to change. It's not just still, it's preserved. Preserved by density differences too subtle to see and too strong to ignore. The moment you dive through it, you can feel the resistance. Not like hitting a wall, but like crossing into a different time. The temperature shifts, the light dulls, and the chemistry changes so completely that you almost expect the water itself to push you back. But it doesn't. It lets you pass, even if just for a moment, as a witness to a world divided not by violence or movement, but by the quiet insistence of nature's own rules. This layering isn't an accident. It's balance. Not the kind that sways or drifts, but the kind that waits, undisturbed, reminding us that sometimes the most powerful divisions are the ones we can't see, only feel when we're deep enough to notice. And once you begin to understand that this separation of water, this quiet, undisturbed layering, is real and lasting, it opens your eyes to the world living within it. Because those layers aren't just chemical boundaries, they're neighborhoods. And every neighborhood has its own kind of life, each shaped by the rules of the water it lives in, each following a rhythm most of us will never hear. Up near the surface, things feel familiar. Oxygen is plentiful, and microbes behave the way we expect them to, feeding off organic matter and breathing much like we do, using that oxygen to fuel their simple, invisible lives. But go deeper, step by step through those silent boundaries, and the rules change with the chemistry. As the oxygen fades, a different kind of metabolism takes over, something older, something more resilient. Microbes that live just beneath that boundary layer aren't interested in oxygen anymore, because they've adapted to live without it. Down there, sulfur is the currency of survival. These bacteria, the sulfur reducers, thrive in a space where hydrogen sulfide is plentiful and oxygen is absent. They take in sulfur compounds, break them down, and release energy in a way that would poison most of the living world. To them, that thick, suffocating gas isn't a threat. It's food. They live off what we run from, and as you keep sinking, deeper still, the sulfur reducers give way to another group entirely: the methanogens. These microbes operate in a zone even more cut off from the world above, where the water is heavy with decay and completely devoid of oxygen or light. They take the broken-down remnants of organic matter, the leftovers of everything that has ever died and drifted down, and they do something extraordinary with it. They make methane. Not from fire, not from combustion, but from chemistry alone. It's a quiet, slow process, molecule by molecule, shaping gas from the pieces of forgotten life. These organisms aren't fast or flashy, but they're persistent, and they've been working this process since long before there were animals to speak of. There's something almost unsettling about it, standing, or rather, floating, at the edge of that realization. Because the deeper you go, the older the life gets. Not in age, but in design. These aren't modern organisms reacting to a changing world. They are ancient survivors, running systems of metabolism that trace back to Earth's earliest days. We tend to think of life as something climbing upward, more complex, more advanced. But here, it's the opposite. The deeper you go, the simpler and more essential it becomes, like peeling back layers of time. And each layer, each group of microbes, has carved out a niche so specific, so perfectly matched to its chemistry, that nothing else could live there. What's remarkable is not just that these processes exist, but that they all coexist, not in conflict, but in sequence. Each microbial layer depends on the one above it, breaking down the byproducts that drift down like whispers from another world. It's a chain of invisible laborers, one group passing its waste to the next, turning death into fuel, and fuel into gas, over and over. And if you listen to it, not with your ears, but with your sense of wonder, it tells a story not of chaos, but of order, written in silence and time. It's not our kind of life, but it is life, stubborn and enduring, carved into the very chemistry of the deep. And when you finally start to see how these ancient microbes live, how they pass energy along quiet, invisible chains beneath the surface, you can't help but wonder what this says about the beginning of it all. Not just about blue holes or strange underwater landscapes, but about Earth itself, about what it was like when the sky was still young, when oxygen hadn't yet filled the air, and life was something clawing its way into existence in a world that didn't welcome it. That same chemistry, that same quiet resilience buried deep in the layers of these sinkholes, may be one of the last working blueprints we have of what life used to be, before it was anything we'd recognize. On early Earth, the world wasn't bathed in oxygen or light. It was a place of volcanic breath and thick gases, where ultraviolet rays rained down through a sky that offered no protection. And in that hostile environment, life didn't begin with grand creatures or green leaves turning sunlight into sugar. It began in the dark, in water, in chemistry. These microbes that now cling to the bottom of blue holes, the sulfur reducers, the methanogens, they're not fossils. They're survivors. They haven't changed much because they never had to. The conditions they evolved in still exist down there, locked away from the surface by pressure, density, and time. And so, in a way, to study them isn't just to observe an ecosystem. It's to open a window into a version of Earth we'll never stand on, but which still pulses quietly in the deep. What's striking is how simple the rules were back then. No oxygen, no plants, no animals, just raw chemistry, driven by minerals and heat and time. Life had to be clever with what it had. It used sulfur instead of oxygen. It made methane instead of breathing it in. And it didn't need the sun. That's something that humbles you, if you let it. Because we often talk about life as if it's fragile, as if it needs comfort, light, the right kind of sky. But that's only true for us. The first forms of life didn't have any of those things, and yet they found a way. What you see in these isolated, stratified waters is not just survival, it's memory. A biological echo of how life once solved the problem of existing with nothing but rocks, water, and time. And the more we study these systems, the more we realize that early life didn't need much to get started. It didn't wait for Earth to become pleasant. It made use of what was already here, gases that we now find toxic, energy sources we barely understand, chemical gradients born from the simple fact that hot water meets cold, or that light can't reach beyond a certain depth. That's how it began, not with noise, but with quiet persistence. And so the story of blue holes, of the chemistry in their depths, isn't just about a strange place on Earth. It's about where we came from. It's a reminder that before there were trees or fish or people, there were microbes working in the dark, inventing metabolism from the bottom up, writing the first lines of the story we're still living in today. Part 5. Astrobiological Importance. Imagine a place on Earth where sunlight barely touches the water, where oxygen disappears the deeper you go, and life, if it exists at all, must cling to existence in silence and shadow. Blue holes are not just geological curiosities or marine wonders. They are time capsules, sealed beneath the ocean's surface, carrying whispers from Earth's deep past. And for those who gaze not just at the stars but into the oceans with questions of life beyond this planet, these sinkholes hold a particular kind of gravity. Astrobiologists, those curious souls who spend their lives wondering if we're alone in the universe, are drawn to blue holes not just because of what they are, but because of what they mimic. Down there, past the layers of shimmering sunlight, beyond the reach of most marine life, conditions begin to echo those of distant frozen moons, like Europa and Enceladus, or the red plains of ancient Mars. These are environments that challenge life with extremes: low oxygen, high pressure, and chemical compositions that would make most forms of known biology falter. And yet, life finds a way. In the darkened waters of blue holes, microbial communities thrive in isolation, some relying not on sunlight, but on chemosynthesis, extracting energy from sulfur or methane in ways that feel almost alien. It's not unlike what scientists suspect could be happening beneath the icy crust of Europa, where oceans lie beneath miles of frozen surface, warmed not by sunlight, but by the tidal flexing of Jupiter's gravity. When researchers drop into these holes, sometimes literally, suspended on ropes, carrying gear that measures things like temperature, salinity, and microbial DNA, they're not just diving into the ocean, they're diving into analogs of other worlds. Every sample pulled from those layers could be a mirror to what life might look like elsewhere, in places untouched by sun, shaped by time and chemistry. It's the kind of exploration that doesn't need fiction to feel like science fiction. Standing on the edge of a yawning blue sinkhole, you get the sense that you're not just looking into the Earth, you're looking across time and space. There's a kind of reverence in the way these scientists speak of their work. They're not chasing headlines or discoveries that glitter. They're chasing understanding, quietly, patiently. They sift through ancient sediment layers, through microbial mats that haven't seen oxygen in thousands of years. They run their fingers along the thin line where saltwater meets freshwater, where temperature shifts mark transitions between ecosystems. And all the while, they're thinking of places millions of miles away, not in grand speculative gestures, but in the small, methodical parallels that science demands. They're looking for survival strategies, how life adapts, endures, evolves. Because if it can do that here, in this cold, dark pocket of our own world, then maybe it can do it there too. These holes don't speak in words, but they hold memories. Chemical, biological, geological, etched into every layer. For those trying to piece together the grand puzzle of life in the cosmos, blue holes are not just relevant, they are essential. They remind us that alien does not have to mean distant. Sometimes, it's right beneath our feet, waiting in the deep. And when you begin to understand why these places matter so deeply to those who study the possibility of life beyond Earth, the next question that settles in your bones is perhaps the most human of all. How does anything survive in such a place? Not just endure, but truly survive. In the stillness of darkness, under the weight of pressure, wrapped in water that's laced with poison by most definitions. It's a question not asked out of curiosity alone, but out of kinship. Because in some way, we've all wondered what it means to survive when the conditions around us seem bent on silence. Down in the depths of a blue hole, there is no sun to drive life's rhythms. The pressure is crushing, almost mocking, and oxygen becomes scarce, sometimes vanishing entirely. Yet in these hostile depths, Life has not only clung on but written entirely new rules for itself. And it doesn't scream its presence. It moves slowly, whispers chemically, and builds entire ecosystems, molecule by molecule. These are not the kind of organisms you'd see in a nature documentary. No flashing colors, no darting fins. This is life reduced to its barest, most elegant function: persistence. There are microbes down there that make their living from sulfur, breaking down compounds we'd consider toxic in almost any other context. They form mats, soft, filamentous colonies that coat rocks and sediment like a microbial skin, and instead of taking from the sun, they take from the chemistry around them. It's a slow metabolism, measured in the quiet language of electrons, in a dance of molecules where every bit of energy is precious. These organisms don't just survive the lack of oxygen, they've evolved to see it as unnecessary. Some even find oxygen poisonous, a dangerous byproduct of more surface-bound life. In the layers where hydrogen sulfide creeps in, where you or I would pass out in moments, they thrive, as though the Earth whispered a different blueprint into them. It's not just that these organisms exist, it's how they endure the unthinkable with patience no human mind can mimic. Where we build suits and machines to shield ourselves from pressure, these creatures incorporate it, shape their membranes and proteins to bend, not break. Where we would see darkness and say life can't happen here, they've used it to build stability, an unchanging world where evolution doesn't need chaos, just time. And in a way, their entire existence speaks to a resilience that feels deeply familiar. Stripped of sunlight, under stress, exposed to what should be poison, somehow they make it work. They keep going. What's more, these communities often live in total isolation. Some blue holes are cut off from the open ocean almost entirely, meaning the organisms within have been evolving along their own quiet paths for thousands of years, maybe longer. They haven't had a conversation with the rest of life on Earth in a very long time. But they've never stopped listening to their own environment, adapting in microscopic steps. There's a beauty to that kind of solitude. One that doesn't seek attention, only continuity. And as people, we can't help but see something of ourselves in that. Because whether we're drifting through grief, or fighting to stay afloat in a world that doesn't always make space for us, that quiet tenacity, the ability to find a foothold in the dark and not let go, is something we recognize, even if we can't name it. Life in the blue holes doesn't shine or speak or rise quickly, but it endures. Not by resisting the darkness, but by folding it into its nature. And that, in its own way, is a kind of brilliance. And once you begin to understand how life adapts, how it bends without breaking in the darkest, most unforgiving places, you begin to see a pattern, one that scientists have come to rely on. The idea that Earth itself can be a stand-in, a proxy, a rehearsal space for the alien. Not because we're trying to imagine life out there through fiction or fantasy, but because life down here, in its strangest corners, already speaks in the same language we expect to find out there. This is where the concept of analogs takes shape. Places on Earth that mimic the conditions of distant worlds, not in appearance, but in the deeper ways that matter. Temperature, chemistry, pressure, isolation. To someone looking in from the outside, it might seem like guesswork, like a form of scientific make-believe. But to the people who walk up to a steaming volcanic field in Iceland or lower sensors into the frozen lakes of Antarctica, the work is anything but abstract. It's physical, immediate, and humbling. They stand in biting wind, kneel by sulfur springs that smell like rot, send robotic probes into subglacial darkness, not for the thrill of extremes, but to ask a question that has haunted us for generations. If life exists elsewhere, what would it look like? And how would we recognize it? And if you want to answer that, you need somewhere to start. Somewhere close enough to study, but alien enough to matter. Analog sites become our practice grounds, not for predicting life exactly, but for understanding the limits of what biology can tolerate. A toxic brine pool at the bottom of the sea tells us something about what salt-saturated oceans might allow on a moon like Europa. A desert cave sealed off from sunlight teaches us how microbial life might survive in the subsurface of Mars. We're not pretending these places are those worlds. We're learning to read the signs they share. The same way a musician practices scales not to copy a song, but to be ready for anything the melody might ask. And always, at the heart of this effort, is something very human. We test these analogs not just with instruments, but with hope. Hope that if life found a way here, in Earth's forgotten corners, it might have done the same elsewhere. That some icy moon, orbiting a gas giant millions of miles away, might have its own quiet ecosystem, waiting beneath the ice, unseen but real. That the story of life is not uniquely ours, but part of a longer, wider narrative that reaches far beyond our skies. To think like that takes more than imagination. It takes discipline, patience, and the willingness to follow evidence even when it leads you to places that feel nothing like home. And that's what analogs give us. A foothold. A frame of reference. They let us explore the unknown without leaving the ground, reminding us that sometimes the path to the stars begins in the soil, the salt, the silence of Earth itself. They ask us to look closer, not to dream less, but to dream smarter. Because out there, if life exists, it won't be waiting on a welcoming world. It'll be surviving, as it always has, in places that don't offer comfort, only the raw materials for resilience. And when we look into our own extremes, those sharp, quiet places, we begin to understand how to listen for life, even when it doesn't shout. And after studying these analogs long enough, these distant corners of our planet where life clings to the edge of what seems possible, you begin to notice not just the environments themselves, but the patterns of the life that lives within them. The way microbes organize, the way they feed, even how they interact with one another in silence. All of it begins to feel eerily familiar to what scientists have come to expect beneath the frozen crusts of moons like Europa and Enceladus. Not because we've seen those alien oceans firsthand, but because the rules life follows down there in the blue holes are the same rules it might follow out there in the darkness between stars. You watch how these microbes operate, how they form layered communities, stratified, specialized, each depth serving as a different neighborhood with its own chemistry, its own rhythm. Some sit near the upper boundaries where the last traces of light might still wander in, while others descend deeper, into the sulfide-rich blackness where oxygen disappears completely. And in that descent, you see something that doesn't just resemble survival, it resembles strategy. Division of labor, resource management, cooperative metabolism, microbes feeding off the waste of other microbes, forming tiny, efficient cycles that keep everything turning. That kind of structure isn't chaos. It's community. And if you were to imagine what life beneath Europa's crust might look like, cut off from the surface, encased in ice for eons, you'd imagine something a lot like this. What makes it all the more compelling is how little these organisms seem to need from the outside world. No sunlight, no fresh oxygen, just gradients of temperature, of chemicals, and the ability to exploit them. Scientists believe the oceans on Europa and Enceladus might contain those very same gradients, fed by hydrothermal vents on the seafloor or fractures in the ice that release minerals into the water. If microbes can find a foothold in that delicate balance here on Earth, then it isn't too far a stretch to think they might do the same on a moon where conditions align just enough. It wouldn't be life as we know it, not in form or comfort, but it would be life that understands how to use every scrap of energy it can find, how to turn scarcity into stability. And when you hear the scientists talk about this, there's a kind of quiet awe in their voices, not because they believe we're on the brink of discovery, but because these echoes, the ones between Earth's deepest holes and the cosmos' icy vaults, feel too clear to ignore. The similarities aren't about appearance. They're about process, about need, about behavior, about life stripping itself down to the fundamentals and still managing to build something complex, something sustainable, out of almost nothing at all. It's not that we expect to find Earth out there. It's that Earth keeps showing us how adaptable life can be. And in those blue holes, in those silent underwater cathedrals, we catch a glimpse of what that might mean. Not in grand, cinematic gestures, but in the quiet persistence of things too small to see, yet powerful enough to rewrite our understanding of where life might be hiding and how it might endure. And when you finally begin to appreciate the quiet strategies life employs in places like blue holes, something deeper starts to emerge. Not just survival, not just resemblance to distant worlds, but evolution itself unfolding in ways most of us never get to see. These aren't just isolated environments. They're living laboratories, carved by time, sealed by chemistry, and left alone long enough to let nature conduct its own long, patient experiment. And if you pay attention, what you see inside them isn't just life surviving. It's life inventing, adapting, rewriting the rules it once followed. Inside these sinkholes, The usual environmental cues are stripped away. No tides to stir things up, no seasons to guide behavior, and very little exchange with the outside world. In a way, it's like pressing pause on the broader rhythms of the planet and seeing what life does when left to its own devices. What emerges isn't chaos, it's ingenuity. You find microbes that build entirely different metabolic pathways, that alter the structure of their membranes to withstand pressure or toxicity, that engineer ways to thrive on gases and chemicals we once thought of only as byproducts or waste. The biochemistry doesn't just stretch, it transforms, becoming something unorthodox, yet stable, like a new dialect in the language of life. And this is where the story becomes personal. Because in those mutations and biochemical detours, we see resilience not just as a biological function, but as a form of persistence we recognize in ourselves. Life inside blue holes doesn't wait for things to return to normal. It makes new normals. It adapts by altering the very core of how it breathes, feeds, reproduces. It doesn't complain when the oxygen runs low. It rewires its engines. And that ability, that flexibility under pressure, tells us something profound about what evolution is really capable of when stripped of comfort, when forced into a corner and told to figure things out or fade away. What scientists learn in these holes challenges what we once thought was universal. The assumption that all life needs oxygen or sunlight or even a typical cell structure begins to dissolve the deeper you go. These aren't just variations, they're departures, revealing that life can take paths we've barely imagined. And in studying those paths, researchers aren't just looking back at what Earth used to be, or forward to what alien life might resemble. They're gaining a broader understanding of life as a force, one that isn't bound by a narrow definition, but instead shaped by context, by challenge, by time. For all our technology, all our simulations and models, sometimes the clearest lessons come from just watching what's already there. Blue holes show us what life does when it's boxed in, cut off, tested again and again over centuries. They show us what it means to not just adapt to hardship, but to evolve through it, elegantly, efficiently, and without fanfare. And in that silence, in that slow churn of microbial resilience, there's a kind of wisdom. A quiet reminder that life, when given even the slimmest of chances, will reach, shift, and find a way forward, even in places where nothing should be alive at all. Part 6. Dangerous Depths. There's something quietly humbling about descending into the heart of a blue hole. The surface might shimmer with an almost inviting calm, but beneath that thin mirror of sunlight lies a world that doesn't welcome mistakes. Divers who enter these deep, cylindrical voids face more than just a test of skill. They're stepping into a realm that plays by different rules, one where the body and mind can betray even the most experienced. As the pressure builds with every meter, nitrogen begins to behave like a sedative, clouding judgment and slowing reaction. It's not a sudden loss of control, but a gentle slipping, like falling asleep at the wheel. And in these depths, just a few seconds of confusion can mean the difference between surfacing or never being seen again. There's a silence down there that stretches long past peace, one that makes a person realize how far removed they are from the surface. Visibility can shift in an instant, with suspended particles and the peculiar shape of the sinkhole causing the walls to vanish from sight, turning up and down into a guessing game. Divers call it disorientation, but that word doesn't quite capture the intimate fear of looking around and no longer knowing where you are, or worse, which way is out. Light no longer filters down in beams, it's swallowed whole. And the vertical drop-offs, sudden and absolute, give the illusion that the seafloor has vanished, when really you've just crossed a threshold into darkness that doesn't care who you are. Then there's the buildup of gases, the silent saboteurs. Oxygen becomes toxic under pressure, and carbon dioxide doesn't always get expelled the way it should. Divers might begin to breathe just a bit faster without realizing it, their bodies working harder, nerves flickering with unease. Panic isn't loud. It begins in the chest, as a quiet certainty that something isn't right. In a place like this, where the way out is straight up and the margin for error is razor thin, panic can seal a person's fate before they even act on it. And yet, they go in. Scientists, explorers, those searching for something more than what the surface offers. They go in knowing what waits down there, because beneath all the risk lies something untouched, something eternal. The danger isn't always the depths themselves, It's forgetting that the blue hole doesn't forgive. It only takes. And when you understand how the depths show no mercy, it becomes all the more sobering to look back at the people who dared to test them and didn't come back. Not names on plaques or numbers in a report. These were people with families, with routines, with lives full of small, ordinary joys, who slipped beneath the surface one day and never rose again. Take the story of Yuri Lipsky, a diver with experience but perhaps not enough preparation for the blue hole in Dahab, Egypt. What happened to him was captured on his own helmet camera, and while the footage isn't for everyone, it has become something of a warning told in silence and movement rather than words. He descended too quickly, reached a depth far beyond recreational limits, and his breathing, steady at first, began to quicken as the narcosis took hold. There was no explosion, no dramatic rupture, just a slow spiral into confusion. The last moments are hard to watch, not because of what you see, but because of what you recognize. A human being realizing too late that they are no longer in control. There are others, those who came close but lived to carry the weight of those moments. Sheikh Exley was one of the most respected cave divers in the world, someone who understood better than most the mechanics of deep diving and the psychological toll it could take. He made it to the very limits of human depth in a blue hole in Mexico, and though he survived many dives that others wouldn't dare attempt, his final descent, an attempt to reach more than 300 meters, was the one that took his life. In the aftermath, those who studied his logs and gear found no panic, no equipment failure, just the silent arithmetic of depth, time, and human limits adding up to something irreversible. Then there's the kind of story that doesn't end in death, but lingers all the same. Divers who returned with their minds not quite intact, their memories fractured, their confidence hollowed out. One man recalled surfacing from a blue hole in the Bahamas, having lost track of nearly 20 minutes, unsure of where he'd gone or how he'd even gotten back. He hadn't blacked out, not exactly. He remembered shapes, a voice that wasn't there, the feeling of drifting toward a wall that kept moving further away. He didn't dive again for years, not because he was injured, but because he'd glimpsed that quiet, cold indifference waiting down there. These aren't tales to scare. They are reminders, stitched into the history of these places. Each accident, each near miss, leaves behind a trail of hard lessons and quieter truths. The blue holes don't rage or scream. They just remain, deep and unchanged, waiting. And when the water closes over someone's head, it doesn't matter how experienced they are, or how calm they feel. It matters only that they remember what they're swimming into. Because in these ancient voids, memory fades, judgment clouds, and time stretches longer than it should. And just when you think the dangers are all physical, depth, pressure, time, you come face to face with something less visible but no less unforgiving. Deep within many blue holes, beyond the reach of natural light, there lies a layer that doesn't move, doesn't swirl, but waits in stillness. It's called hydrogen sulfide, and it's not just some chemical term scribbled in a diver's textbook. It's a veil of poison, lying like a second ocean within the first. To pass through it is to enter a place the body was never meant to go. The water shifts from blue to black in an instant, and even before the diver fully realizes it, the taste in the regulator changes, turning foul and metallic, the way rot smells after rain. What makes it worse is how quiet the onset can be. A diver might feel the sting first, like fine glass against the eyes. Not sharp enough to scream, but enough to blur the world around them. It doesn't take much. Just a leak in the mask, a seal that didn't quite hold, and the hydrogen sulfide starts to seep in. Eyes redden, vision clouds, and before long, the diver is swimming half blind, trying to orient themselves in a place already disorienting by design. Breathing it in, even through the protection of standard gear, is a gamble. The gas attacks the lungs with a slow kind of violence, inflaming the tissue, making each breath feel heavier, more labored. And it's not just the lungs. It moves through the bloodstream like a shadow, interrupting the body's ability to use oxygen. Which means that even with air in the tank, the body begins to starve on the inside. There was a woman once, a researcher, careful in every way that mattered, who dipped into the lower layers of a blue hole in the Caribbean. She hadn't planned to stay long, just long enough to collect samples, take a few readings. But in that thin layer of hydrogen sulfide, her mask fogged, and her hands began to tremble. She surfaced shaken, coughing, and her team said she didn't speak for nearly 10 minutes after taking off her gear. Her eyes were red for days. It wasn't injury in the dramatic sense, no dramatic rescue, no collapse on the boat. It was quieter than that. A slow, creeping understanding that what lies down there doesn't need to shout to be dangerous. It just needs to be still, and hidden, and patient. That's the thing about these waters. They don't lash out. They invite, they pull, they seduce with beauty and mystery. But beneath it all, beneath the blue that turns to black and the silence that presses too close, there are elements the earth has buried for reasons of its own. And when you meet them face to face, you realize some places were never meant to be touched. Some layers weren't meant to be crossed. And if the toxins don't reach you, if you're careful with the pressure and smart with your gas, there's still another kind of weight waiting for you down there. One that no equipment can filter out. The mind, you see, behaves differently when it's pressed into silence, boxed in by rock on all sides, and swallowed by a darkness so complete it erases not just the landscape, but the idea of direction itself. It's one thing to walk into a dark room and feel around for a switch. It's another to glide through a submerged tunnel no wider than your own shoulders, unsure if it opens up ahead or tightens into something you can't escape from. That does something to a person. And it's not fear in the loud, panicked sense. It's quieter, more patient. It sits in the chest like cold water, growing with each inch forward. Some divers speak of a moment when they had to choose whether to turn back or push through a narrow chute barely larger than their tank. Their breath loud in their ears, the only sound their own heartbeat. One misjudged angle and you're stuck. There's no turning around easily, no standing up or backing out like you might on land. Every movement must be measured, deliberate, almost rehearsed. And it's not just the tightness of the space. It's the absence of light that makes everything feel infinite and claustrophobic at the same time. You're floating, but you feel the weight of the cave pressing in on all sides. You're moving, but sometimes it feels like you're not going anywhere at all. That kind of environment strips a person down to their instincts, and sometimes those instincts get it wrong. Even the most practiced diver can start to feel time bend in those tunnels. Minutes feel longer, breaths feel shorter. You check your gauge again and again, even though you just checked it. You shine your light down a corridor and find that the beam ends in nothingness, like it's being swallowed rather than reflected. And the mind, when faced with that kind of uncertainty, starts to conjure shapes out of shadows, movements that aren't there. You begin to talk to yourself, not always out loud, but in that urgent internal voice that's trying to keep you calm, trying to keep you from making one small mistake. Because down there, one small mistake is all it takes. And it doesn't leave you when you resurface. For some, the tunnel stays with them in dreams, tight, silent, endless. For others, it becomes a kind of ghost, a memory that visits when the world is too quiet. These are places where the earth narrows, where time slows, and the body is forced to reckon with itself. And when you find yourself alone in a dark passage 30 meters under the sea with no room to turn and no margin for panic, that's when you understand. It's not the darkness that's the enemy. It's what it brings out in you. And once you've made it through the narrow places, past the darkness and the silence, past the turning of the mind against itself, you begin to understand that reaching depths beyond 100 meters isn't just another challenge. It's an entirely different world, and one that refuses to be approached lightly. At that level, everything you knew about diving starts to bend, not just in theory but in practice, in the way your body reacts, in the way your equipment performs, and in the way time itself begins to stretch and distort. Breathing isn't just about staying calm anymore. It becomes a science of precision, a balancing act of gases that must be mixed, monitored, and measured down to fractions, because the wrong concentration can dull your senses or shut them down entirely. This kind of depth doesn't welcome casual entry. It demands months, sometimes years of preparation, not only in physical endurance but in discipline of thought. You train to react not with instinct, but with protocol. There's no room for improvisation when you're that far beneath the surface. Everything must be planned and pre-planned, written out, rehearsed, and repeated until it becomes something close to muscle memory. And still, even with all that training, there's no guarantee, because deeper diving introduces problems you simply can't encounter at shallower levels. Your decompression time multiplies, A dive that takes minutes going down might require hours to come back up safely. A misstep in the math means more than discomfort. It means you don't return. Divers at these depths rely on technology that doesn't just support their survival. It extends their limits. Rebreathers, mixed gases like trimix, redundant systems for light and air, computers that track every nuance of depth and time. But machines don't make decisions. People do. And people, no matter how seasoned, are still human. There was a man, quiet and methodical, who trained for over a year to attempt a 120-meter descent into a blue hole off the coast of Belize. Every variable had been accounted for, every contingency mapped. And yet, during ascent, a small delay in switching gas mixes caused him to black out. He was brought back, revived on the surface. But when asked about it later, he didn't speak in fear or failure. He just said, "You don't get second chances down there. I got lucky. That's all it was." And that's the truth of it. At that kind of depth, you can't afford to rely on luck, even though sometimes it's the only thing that tips the scale. You prepare because you must. You plan because the margin for error doesn't just shrink, it disappears. And still, there are those who go, not because they underestimate the risks, but because they understand them better than most. They dive not to defy nature, but to witness it. To see what waits in the quiet places no one else has touched. But before they ever take that first step into the water, they know. If something goes wrong down there, there's no shortcut home. Only the long, careful way back, or none at all. Part 7. The Chemistry of Isolation. Imagine drifting quietly over the surface of a blue hole, the sunlight warm on your back, the water impossibly clear, the surface calm, deceiving in its serenity. Just beneath, though, a deep, dark shaft opens like the throat of the earth itself, descending hundreds of feet into stillness and silence. It seems like any fish, any diver, any breath of current could pass freely in and out. But once you cross a certain depth, the rules change. The water is still there, the ocean still surrounds it, yet something invisible stops the oxygen from following. It's like a door without a lock, a path without a traveler. And the reason is both simple and profoundly indifferent to the needs of life. Blue holes, in their depth, become disconnected not physically, but chemically. They are shaped in such a way that while the top layers mix freely with the surrounding sea, the deeper zones stay motionless, untouched by wind or wave. And without that motion, there is no churn to carry down the oxygen. The deeper water becomes dense, heavier, and it sits in place, layer upon layer, like a silent archive of time. And like an old room never opened, the air doesn't reach it. Not because the door is locked, but because nobody opens it. Now imagine you're in a room, window open, breeze blowing. You think the air is circulating. But if you leave the basement sealed for weeks, it grows stale. The open window upstairs means nothing to that air below. The same happens here, just on the scale of centuries. Without circulation, oxygen never makes the journey. And where oxygen is absent, different chemistries awaken. Hydrogen sulfide, the gas that smells like rotten eggs, begins to rise, produced by bacteria that don't need oxygen to live. These bacteria thrive in a world most life can't tolerate, feeding on sulfur and ancient carbon. They live in silence, completely unbothered by our rules. And they do so because oxygen never comes to disturb them. A diver who drifts too low into that stillness will feel it. Not just in their gear readings, but in the air of the place. The light dims, in an unusual way. The water feels thicker, more inert. And the knowledge that this water has been untouched, unmixed, undisturbed for possibly thousands of years presses on you with a quiet weight. There's no oxygen down there, not because it was stolen or used up, but because the chemistry of the place never allows it to arrive. The shape of the hole, the weight of the layers, the absence of movement, together, they keep the lower depths locked in their own time, as if the ocean, in its vastness, decided to press pause in a single narrow corridor of depth. That isolation creates more than just a lack of air. It becomes a silence in the language of chemistry. Without oxygen, the usual conversations of decay, respiration, and transformation take different paths. It's like entering a library where all the books are written in a different script, strange, old, and utterly indifferent to who you are. And all of this happens not miles beneath the Earth, but just a few dozen meters below the sunlit surface. There, a barrier you can't see or touch holds back the most essential element of life. Not by force, simply by stillness. Imagine drifting quietly over the surface of a blue hole. The sunlight warm on your back, the water impossibly clear, the surface calm, deceiving in its serenity. Just beneath, though, a deep, dark shaft opens like the throat of the earth itself, descending hundreds of feet into stillness and silence. It seems like any fish, any diver, any breath of current could pass freely in and out. But once you cross a certain depth, the rules change. The water is still there, the ocean still surrounds it, yet something invisible stops the oxygen from following. It's like a door without a lock, a path without a traveler, and the reason is both simple and profoundly indifferent to the needs of life. Blue holes in their depth become disconnected not physically, but chemically. They are shaped in such a way that while the top layers mix freely with the surrounding sea, the deeper zones stay motionless, untouched by wind or wave. And without that motion, there is no churn to carry down the oxygen. The deeper water becomes dense, heavier, and it sits in place, layer upon layer, like a silent archive of time. And like an old room never opened, the air doesn't reach it. Not because the door is locked, but because nobody opens it. Now imagine you're in a room, window open, breeze blowing. You think the air is circulating, but if you leave the basement sealed for weeks, it grows stale. The open window upstairs means nothing to that air below. The same happens here, just on the scale of centuries. Without circulation, oxygen never makes the journey. And where oxygen is absent, different chemistries awaken. Hydrogen sulfide, the gas that smells like rotten eggs, begins to rise, produced by bacteria that don't need oxygen to live. These bacteria thrive in a world most life can't tolerate, feeding on sulfur and ancient carbon. They live in silence, completely unbothered by our rules. And they do so because oxygen never comes to disturb them. A diver who drifts too low into that stillness will feel it. Not just in their gear readings, but in the air of the place. The light dims, in an unusual way. The water feels thicker, more inert. And the knowledge that this water has been untouched, unmixed, undisturbed for possibly thousands of years presses on you with a quiet weight. There's no oxygen down there, not because it was stolen or used up, but because the chemistry of the place never allows it to arrive. The shape of the hole, the weight of the layers, the absence of movement, together, they keep the lower depths locked in their own time, as if the ocean, in its vastness, decided to press pause in a single narrow corridor of depth. That isolation creates more than just a lack of air. It becomes a silence in the language of chemistry. Without oxygen, the usual conversations of decay, respiration, and transformation take different paths. It's like entering a library where all the books are written in a different script, strange, old, and utterly indifferent to who you are. And all of this happens not miles beneath the earth, but just a few dozen meters below the sunlit surface. There, a barrier you can't see or touch holds back the most essential element of life. Not by force, simply by stillness. And when you understand that oxygen doesn't simply arrive on its own, you start to see how the design of these places, the very shape of the blue hole, plays a quiet but commanding role in keeping the deep cut off from the living rhythm of the sea. It isn't just about depth or stillness. It's about how these holes are shaped like vertical traps for time, how the narrow mouths at the surface act like the neck of a bottle, allowing some contact with the outside, but never enough to stir what's resting below. If you were standing at the mouth of a deep canyon, you'd feel the wind rush through, carrying scent, sound, and life with it. But if that canyon narrowed into a crevice halfway down, and the air grew heavier the deeper you went, then eventually, no matter how strong the wind above, it would never reach the bottom. That's the reality in a blue hole. Currents, even strong ones, move like dancers. They need space, momentum, and room to turn. But when they meet the tight entrance of a blue hole, they lose their grace. They slow, stumble, and by the time they've slipped in, there's no energy left to reach the bottom. What little movement there is remains confined to the upper levels, where sunlight and warmth still have a say. Below that, everything settles, not by choice, but by the quiet rules of density and structure. The water near the bottom is colder, heavier, and saturated with minerals and compounds that don't mix easily with the lighter waters above. You can think of it like oil and water in a glass, different, stubborn, unwilling to blend without force. But here, there is no spoon to stir, no hand to mix. Nature lets them rest as they are, and they obey. To a human, it's a bit like walking into a cathedral that's been closed off for centuries. The dust in the air doesn't move, the silence is heavier than you expect, and something about the architecture itself prevents change. It isn't hostile, but it's unmoved by your presence. That's what lack of circulation feels like here. Not just a physical stillness, but a kind of refusal to participate in the surface world's chaos. These holes, with their narrow openings and layered waters, don't resist life. They simply have no need for it anymore. And so life adapts in strange ways, or doesn't survive at all. It's not dramatic, it's not loud, it just is. The beauty and eeriness of it all is that the isolation is earned not through violence, but through quiet imbalance. A little heavier here, a little tighter there, and the sea's ability to breathe into the deep is quietly silenced. It's an architecture of neglect, where the very design makes sure that once something enters, it stays. And in that permanence, in that chemical solitude, you start to feel the weight of time pressing down. Not years, but entire histories, resting undisturbed in cold, quiet water. And once that isolation settles in, once the water no longer moves and the layers no longer speak to one another, what little oxygen does manage to slip into those deeper pockets finds itself met not with gratitude, but with hunger. Not the kind that shouts or scrambles, but the quiet, relentless appetite of microbes, ancient, invisible laborers who have waited in the shadows with patience longer than memory. You won't see them, not with your eyes, but they're there in numbers that stretch the meaning of abundance, feeding slowly, methodically, and without pause. Down in those darker layers, these microbes perform respiration, not with lungs or breath, but with chemistry. They take in the trace oxygen that drifts down and they use it, not for movement or thought, but to break apart bits of organic matter that drift in from above. Tiny fragments of life, sunlit and once vibrant, now decaying, find their way into this oxygen-starved realm, and the microbes greet them as fuel. One molecule at a time, they consume what's available, and in doing so, they draw down the oxygen even further, faster than it can be replaced. It's not violent, it's not sudden, it's just work, unseen and uninterrupted. Now, if you've ever been in a crowded room with poor ventilation, you know the air changes, not just in scent but in feel. You breathe out, others do too, and the balance shifts. You might not notice it until it's uncomfortable. But imagine that same process happening in water, among organisms that never stop breathing out chemistry. As the oxygen disappears, the microbes don't die. They adapt. They switch gears, moving to other sources of energy, other electron acceptors. First comes nitrate, then iron, then manganese, and eventually sulfur. Each step leading deeper into a world where life thrives without the thing most of us consider essential. The water itself begins to reflect these changes, building sharp chemical gradients that act like invisible barriers, each one marking a boundary where one kind of life ends and another begins. It's in those gradients that the story of the blue hole deepens. Not just layers of water, but layers of life and death, of consumption and transformation. You might think of it like walking down a staircase where the air changes with each step, not in temperature, but in what it allows to live. From oxygen-rich comfort at the top to a suffocating sulfur-filled silence at the bottom. And all along that descent, the microbes are there, not waiting, not watching, but working, always working. In the end, it's not just the absence of circulation that robs the depths of oxygen. It's the presence of relentless, tireless life, stripping it away before it ever has the chance to stay. And once those layers settle into place, once the oxygen is drawn down and the chemistry shifts, what follows isn't simply a snapshot in time. It's the beginning of a loop, a quiet reinforcement that keeps the deep cut off, decade after decade, century upon century. You might imagine that such stillness would erode over time, that somehow the system would wear down or break open. But in a place like this, time doesn't unwind, it builds. The deeper waters grow more stable, more resistant, held in place not by force but by balance, and intricate feedback. where each small change only serves to preserve the conditions that caused it in the first place. When the oxygen disappears, it sets off a chain of chemical transformations. The microbes adapt, as they always do, and in their wake they leave behind compounds that make the water below even less hospitable to mixing. Hydrogen sulfide, metals, acids, byproducts that rise and hover just beneath the surface of that invisible boundary. These aren't just leftovers, they're barriers. They alter the water's density, its chemistry, even its ability to carry and retain new oxygen. So now, any current that does try to push down, any bit of fresher water that might wander into the depths, finds itself slowed, repelled, not by a wall, but by the simple resistance of imbalance. It's like trying to pour clean water into oil. The shapes might shift, but they do not merge. And there's a kind of memory in that. Not the kind that recalls events, but the kind that preserves structure. The water remembers its own weight, its own layers, its own lack of breath, and anything that enters is slowly made to match it. It's not just that the bottom resists change, it reshapes what dares to descend. And so the isolation isn't just maintained, it's reinforced. The longer the system sits undisturbed, the more firmly it holds. The chemistry that began with a little stillness becomes the reason that stillness cannot end. To a person, it's much like watching a habit become a way of life. At first, you miss a few days, slip into a new rhythm, think nothing of it. But then that rhythm grows comfortable, and soon, it becomes effort, just to imagine stepping outside it. That's what these feedback loops are, small shifts that, over time, build an environment so stable in its silence that even time itself seems hesitant to disturb it. The surface may change, the sea around it may churn, but deep inside the blue hole, the past keeps repeating. Not with noise, not with motion, but with the calm certainty of something that has forgotten what it means to move. And because that stillness holds, because the boundaries between layers resist breaking, what unfolds within those layers is something more than mere separation. It becomes self-containment. A blue hole, at depth, stops being part of the open ocean in any meaningful way. Instead, each layer begins to act like its own small world, closed off not just from above, but from the other layers around it. And inside each of those worlds, the cycle of nutrients, the passing of carbon, nitrogen, sulfur, phosphorus, continues in a loop, unshared and unbroken. It's not that life halts, it's that life adapts to the walls around it, learning to recycle what little it has again and again, because nothing new is coming. Imagine being locked in a room for decades, never starving, never truly thriving either, just learning how to make the most of what's there. The food you eat becomes the waste you produce, and the waste becomes part of the food again. In that closed loop, everything begins to carry double weight. The same happens down here. The organic matter that drifts down from above is broken down slowly by microbes in the upper layers. The byproducts drift lower, entering another world where different bacteria pick them up and convert them again. In the absence of oxygen, these reactions follow different paths. Fermentation, sulfate reduction, methanogenesis, each one tailored to the rules of its own layer, each one producing compounds that remain trapped within. The bottom layers become chemical laboratories untouched by fresh inputs, where hydrogen sulfide accumulates, where phosphate is released from sediments, where nitrogen exists not in the familiar forms of life, but in strange intermediates that belong to an older Earth. And since these compounds don't escape upward with ease, they linger, feeding new reactions, supporting only those organisms that have evolved to thrive under scarcity and strangeness. No ocean current comes to sweep it all away. No mixing brings in fresh supplies, so the balance that exists is delicate, resilient in its repetition, but fragile to any true disturbance. To see it clearly, you'd have to let go of the idea of the sea as a single mixing bowl. In blue holes, it's more like a stack of sealed jars, each holding a different kind of soup, simmering slowly, quietly transforming its contents without ever spilling into the next. And the longer the system remains undisturbed, the more tightly it holds to this order. The nutrient cycles begin to resemble conversations that never leave the room. Private, circular, almost forgotten by the world outside. And in that silence, in that locked structure, the blue hole becomes something rare. Not just a sinkhole in the sea, but a memory of ancient oceans running on rules most waters have long since abandoned. Part 8. Massive Scale and Mapping. There's something quietly humbling about watching a team of marine scientists gather at the edge of a blue hole, their eyes fixed on a circle of impossibly deep, indigo water that doesn't so much sit in the sea as pierce through it. They know what lies beneath is largely unmapped, barely understood, and in some cases, untouched by modern instruments. Standing there, you can sense their curiosity. It's not the kind of curiosity that shouts, but the kind that has grown patient over years of data, dives, and careful risk. Mapping these massive underwater sinkholes isn't just about measurement. It's about reverence for a place where the usual rules don't apply. To understand the true scale of a blue hole, scientists begin with sonar, using sound to draw a picture where light cannot reach. From boats floating directly above, they lower devices that emit acoustic pulses downward into the water. These sounds bounce back, each echo telling them something about depth, slope, and texture. But sonar only gives them outlines, shadows on a canvas. To reach into the contours and trace the hollows, they need more than sound. They need machines that can move with the patience and precision of a diver who knows they're outmatched by nature. That's where ROVs, remotely operated vehicles, come in. Guided from the surface by cable and pilot, they descend into the hole's vertical shaft, lights flickering against the darkness like distant stars, their cameras capturing high-definition footage of every ridge, ledge, and crevice. The ROVs don't just see, they feel. Sensors tell researchers about salinity, temperature, the presence of hydrogen sulfide in toxic layers that sit in the water like clouds frozen in place, and currents that curve sideways instead of down. Then, there are the AUVs, autonomous underwater vehicles, that dive in without a tether, gliding quietly and deliberately through the depths, pre-programmed with paths to follow. They hover like deep-sea ghosts, charting areas too narrow or dangerous for ROVs to reach. Their onboard systems process data as they go, feeding it into three-dimensional models that scientists will spend months decoding. Every pass adds detail to a map that, until now, existed only in imagination. There is something human in the precision. These machines might be built of metal and wire, but every decision behind their design reflects years of human trial and error, of questions asked again and again until the answers began to take shape underwater. And in the control rooms, whether on ship decks or in mobile labs, you see the faces of the people behind the machines: oceanographers, engineers, divers, geologists. They watch the screens not with excitement, exactly, but with a quiet, serious awe. Because what they're looking at is not just depth in feet or meters, it's time itself, layers of it, collapsed into a sinkhole that has been hiding its history from the surface world for tens of thousands of years. You can tell, in the way they speak to each other in low, focused tones, that they know they're witnessing something rare, a shape that was carved long before the first cities rose. A void filled not with emptiness, but with secrets. Mapping it, measuring it, and trying to understand it is not just a technical challenge, it's a human one. And it changes them, every time. And once those early scans and deep dives begin to hint at the scale of these holes, a new kind of question emerges. Not just what they look like or what they hold, but how deep they truly go, and how they compare to others scattered across the globe. That's where the quiet thrill of discovery begins to take shape. Not in a single moment, but in a sequence of milestones that have slowly rewritten what we thought we knew about the ocean's hidden architecture. Scientists and explorers, sometimes with little more than a hunch and old aerial photographs, began tracing these mysterious dark spots in shallow seas, each one a potential doorway to something ancient and immense. It was in this quiet hunt that the Dragon Hole, tucked inside the South China Sea near the Paracel Islands, made its presence known. Local fishermen had spoken of it for years, calling it the Eye of the South China Sea, but it wasn't until 2016 that a team of Chinese researchers confirmed its extraordinary depth, reaching close to 300 meters. That kind of depth doesn't just impress, it unsettles. Because blue holes are not formed by the typical violence of underwater trenches or volcanic activity. They sink quietly, through thousands of years of dissolution and collapse, making a vertical tunnel that runs against the grain of everything we know about how oceans should behave. And so, finding one this deep, this remote, with its inner walls nearly vertical and water layers that haven't mixed with the sea above for millennia, was like finding a forgotten chamber beneath an ancient temple, one nature had sealed shut, but left intact. What made the dragon hole different wasn't just the numbers on a depth gauge, but the silence it held. Researchers who analyzed its layers found that at a certain point, somewhere far below the light, life simply stopped. The oxygen vanished, the water changed, and a kind of otherworldly stasis took over. That invisible boundary wasn't just a scientific curiosity. It struck a chord in the people who saw it firsthand. The divers and technicians knew they were peering into a place where biology, chemistry, and time no longer obeyed the surface world's rules. And for many of them, it wasn't a moment of triumph, but a pause. A moment to recognize how little we still understand about what lies beneath our own seas. Other holes have followed. Each new record approached with both excitement and caution. Whether it was Dean's blue hole in the Bahamas, long thought to be the deepest at around 202 meters, or new findings suggesting even deeper ones lurking off the coasts of islands and atolls, the pattern has always been the same. First comes the suspicion, then the planning, and finally the descent. Not just of machines, but of people. Their time, their effort, and a deep-rooted patience for what the Earth reveals slowly. And when the results finally surface, measurements, samples, cross-sections, they bring with them a strange stillness. A reminder that we are guests in this world, and that some places, no matter how precisely mapped, will always hold something just out of reach. In the end, what defines these milestones isn't the technology, or even the numbers. It's the people who stood at the edge of the unknown and chose to step forward. Not for fame or spectacle, but because they needed to know what was there. And because knowing, even a little, brings us closer to a deeper kind of understanding. One that humbles, more than it explains. And once you've measured depth and mapped contours, even after confirming that you've found something remarkable, the real challenge begins. Because knowing that a blue hole runs deep is one thing, but truly exploring its full reach, both downward and outward, is something altogether different. These places don't offer themselves up easily. What seems like an open shaft from above can become, in the lower layers, a winding network of overhangs, chambers, and lateral tunnels that stretch into the bedrock like fingers of ancient rivers long gone. For the scientists and divers who've made it their mission to understand these spaces, the difficulty lies not just in technology, but in limits. Of time, of light, of the human body, and even of knowledge itself. Picture a diver preparing for descent. They carry not just air and gear, but the weight of precision. Every minute at depth is calculated, every turn planned. But a blue hole isn't a straightforward dive. Its narrow walls and unpredictable passageways turn vertical exploration into a tightrope act. And as you go deeper, the water itself begins to change. Layers of differing salinity and temperature appear, sometimes invisible until you're inside them. These layers can obscure vision, distort instruments, and sometimes halt a mission entirely. Not with violence, but with quiet, creeping risk. And the deeper you go, the more isolated you become. Not just physically, but in a kind of psychological silence that only those who've been in such places truly understand. Now imagine that same complexity, but stretched horizontally. The mouth of a blue hole might be a clean circle seen from above, but beneath the surface, it can balloon outward like an underground cathedral, or splinter into narrow arms that disappear into limestone and darkness. Sending a diver or a machine sideways into those arms is like threading a needle in pitch black, with no promise that it leads anywhere but a dead end, or worse, a trap of overhanging rock and zero visibility. It's not just a matter of skill or courage, it's trust. Trust in your instruments, your team on the surface, and your own instinct honed through repetition. Even the most advanced remote vehicles struggle here. They bump walls, lose signal, or get tangled in silty currents that don't behave the way they're supposed to. Those who've spent years trying to reach the full extent of a blue hole often speak not of conquest, but of restraint. They've learned when to turn back. They've learned that some angles of descent can only be tried once, because the risk is too steep and the margin too thin. There are no shortcuts when you're dealing with ancient stone, toxic layers, and tight underwater corridors. And sometimes, even with the most careful planning, the hole simply doesn't allow further passage. That kind of refusal isn't loud. It comes in the form of instruments that won't read past a certain depth, vehicles that can't push forward without braking, divers who know that the cost of one wrong movement could be fatal. Exploring a blue hole, in the full sense of the word, is not about going as far as you can. It's about knowing how far you should go and accepting that some parts may never be reached. There's a humility in that, one that doesn't make headlines, but defines the people who do this work. They return to the surface not just with data, but with something more lasting. A sense that beneath even the clearest waters lies a mystery that resists completion. And that resistance, that quiet refusal to be fully known, is part of what keeps them coming back. And when those explorers return to the surface, carefully, slowly, carrying hard drives instead of treasure, the real work begins, not with fanfare, but with silence, screens, and long hours of interpretation. The maps they bring back aren't like those of cities or coastlines. They're layered, imperfect, living things, and recent projects, backed by better instruments and more patient methodology, have begun to peel away at the unknowns. In places like the Dragon Hole and other less publicized sites across the Caribbean and the Gulf of Mexico, teams have spent years stitching together sonar readings, ROV footage, and chemical samples to form the closest thing we have to a blueprint of these alien environments. What they've found hasn't just confirmed depth. It's unearthed patterns, strange symmetry, sediment layers that read like chapters in a history book written in mud and stone, and vertical zones where life changes or vanishes, suddenly and without clear reason. These maps, painstakingly assembled from countless missions, have shown us that blue holes are not merely sinkholes. They're complex geological systems with collapsed roofs, winding corridors, and in some cases, entire submerged cave networks hidden far beyond what the eye can see. Some are lined with mineral shelves that hint at past sea levels, while others show signs of ancient rainfall long before the ocean reclaimed the space. A few have revealed trapped pockets of fresh water beneath heavy layers of salt, stable against all odds. And in some of these darker, stiller places, microbial life has been found thriving in conditions thought too harsh for anything to survive. Those discoveries, small in form but enormous in implication, have pushed scientists to rethink not just what life needs, but where it might begin. Yet even with all we've seen, the unknown still outweighs the known. There are entire side chambers hinted at but never reached, places where sonar refuses to echo cleanly, and machines return scratched, confused, or simply fail to return at all. There are chemical signatures that don't yet have an explanation, water layers with sudden spikes in acidity or temperature that don't match the surrounding environment, and mineral deposits that suggest geological forces at work, deeper than we can presently reach. And then there's the matter of time, how old these structures really are, and what they've witnessed in the quiet darkness across millennia. No expedition has yet told the full story, and each map, no matter how advanced, is still missing pieces. The people behind this work don't speak in absolutes. They know better. They talk in margins, in likelihoods, in the language of the cautious and the curious. Because each time a new feature is mapped, a new tunnel is scanned, a new sample is taken, it opens up more questions than it closes. And in that uncertainty, they find purpose. Not to dominate these places, but to keep asking, to keep listening, and to keep showing up at the edge of a hole that looks back at them with the same quiet defiance it always has. And as those unanswered questions begin to stack, as the data maps flatten out into gray zones and dead ends, a quieter layer of thinking begins to take hold, the part of the mind that doesn't deal in facts just yet, but in possibilities. Because when you've mapped what you can and the machinery says no more, all that's left is to wonder what lies beyond the edge of the known, not in the reckless sense of myth or fantasy, but in the quiet calculations of those who've seen just enough to know how much more there could be. The deeper, still unmapped sections of blue holes are not just shadows waiting to be illuminated. They are records, sealed away by pressure, darkness, and time, holding what might be the earliest traces of ecosystems undisturbed by the surface world for tens of thousands of years. Some scientists, sitting in dimly lit labs long after their fieldwork ends, speak about these unknown chambers as if they were vaults. Not vaults of gold or relics, but of memory. Places where climate patterns, ancient rainfall, and seismic history might be trapped in sediment layers, undisturbed by currents or storms. These are places that might carry pollen from trees long extinct, or chemical signatures from a time before human hands ever touched the planet. But perhaps more compelling, more quietly charged, is the belief held by some biologists and microbial ecologists that deeper still, in pockets where sunlight has never reached and oxygen is barely present, there could be entire biological systems operating on principles we've never encountered. Not larger creatures, not spectacles, but life so small and so different it's barely recognizable as life at all. Living off of sulfur, iron, or methane, building its own tiny invisible world molecule by molecule, in isolation so complete it borders on otherworldly. For those who have spent their careers near these depths, the speculation isn't about spectacle. It's about significance. It's the understanding that deep within these unmapped reaches could lie answers to questions we haven't learned to ask yet, about life's resilience, about Earth's memory, and maybe even about what conditions could give rise to biology on other planets. And as strange as it sounds, some believe the silence at those depths is not just absence, but preservation. That something waits, not in the dramatic sense, not with intention, but simply because it hasn't been disturbed, and because nature, when left alone long enough, creates in ways we haven't yet learned to imagine. There's humility in this kind of speculation. It isn't loud, it doesn't come with promises. It's the voice of people who've stood at the edge of darkness and returned, not with answers, but with a sense of deepened responsibility. To explore further, yes, but to tread carefully. Because when you look into a blue hole, you aren't just seeing a void. You're seeing the beginning of something, unwritten, unmeasured, and still untouched. And that, more than anything else, is what keeps them returning. Not to conquer what's hidden, but to listen to what might yet be revealed. Part 9. Hidden Connections and Human Traces. In the vast stillness of the ocean, beneath the shimmering skin of sunlit waters, lie the blue holes, massive marine sinkholes that descend like portals into a forgotten world. These dark, silent chambers have captured the imaginations of scientists and divers alike, not just for their haunting beauty, but for the mysteries they continue to guard with the patience only time and tide can understand. Among the many questions they pose, there is one that seems to stir something deeper in our curious nature. The idea that these blue holes may not stand alone, but instead be part of something larger. A hidden network, a subterranean web of tunnels stretching silently beneath the sea floor, connecting one sinkhole to another in a slow and secretive conversation between stone and water. Evidence for these underwater connections is sparse, yet compelling. In places like the Bahamas and the Yucatan Peninsula, divers and researchers have found tantalizing hints. Subtle water flows detected between distant blue holes, changes in salinity and temperature that suggest movement far beyond the immediate reach of the tides, and even traces of chemicals and sediments that appear in one hole and mysteriously show up in another miles away. Advanced sonar mapping and submersible drones have begun to peel back the layers of this puzzle, revealing winding passages and chambers etched over millennia through porous limestone, sculpted by the relentless work of freshwater carving its way through the bedrock long before these caverns were flooded by rising seas. These are not neat man-made tunnels, but ancient roots, fractured, unpredictable, and sometimes so narrow that even modern machines hesitate to enter them. And within this slow unraveling of nature's blueprints, there is a quiet human thread as well. In the depths of some of these blue holes, where light has never touched, explorers have found more than geological formations. They've uncovered bones, tools, and signs of ritual. Long before these holes were drowned, before the seas claimed what was once dry land, humans ventured into them. The Maya, for instance, are known to have used cenotes, which are inland blue holes, for ceremonies and offerings. They lowered their dead into the earth through these sacred mouths, believing them to be gates to the underworld. What's striking is that some of these ancient relics have been found in multiple, seemingly disconnected holes, raising the question of whether our ancestors knew of the tunnels long before we ever suspected them. Not by technology or science, but by some combination of observation, belief, and perhaps oral tradition passed quietly across generations. To imagine ancient people, barefoot and guided by torchlight, threading their way through caverns that we now map with digital sonar, is to understand that the human relationship with these places is not a modern one. It is old and personal, and layered with reverence as much as it is with wonder. And as we explore further, following the faint trails of currents and stone corridors, we are not just chasing geological patterns, but something more elemental. The traces of our own footsteps echoing through deep time, carried along paths carved in darkness by both nature and man. And when you begin to consider the possibility that these blue holes are more than isolated marvels, that they're quietly connected beneath the surface by ancient passageways, your mind naturally turns to what flows through them, and what that flow might touch. It's not just stone and salt water down there, and the water that moves through these subterranean veins, out of sight and beyond easy reach, may carry with it more than we've accounted for. It could shape the very fabric of marine ecosystems in ways we're only beginning to suspect. These underground flows, slow and unseen, don't move like ocean currents do. They're subtle, persistent, and patient, working in silence as they link one part of the seafloor to another, threading through bedrock and emerging sometimes miles away from where they began. What makes these flows matter isn't just the mechanics of water moving from one chamber to another, it's the ingredients they carry. Nutrients leached from ancient sediments, pockets of chemicals from deep geological layers, and even microbial life adapted to darkness and pressure. These are carried in the stream, pulled along by gradients of salinity, pressure, and temperature. When these hidden flows find an exit, through a crack in the reef, a seep along the seafloor, or an outlet in a distant blue hole, they don't just change the water chemistry in that spot, they feed it, they alter the balance, and that, in turn, affects everything that lives there. From the microscopic plankton drifting in the currents, to the larger fish and coral that depend on the right balance of minerals and nutrients to survive. In the midst of this quiet exchange, there's also a subtle story of life responding to invisible change. You see small shifts in coral growth, unusual concentrations of certain species around seemingly unremarkable holes in the seabed, fish that hover in places with no obvious reason to stay. And maybe the people who've lived near these places for generations, the divers and fishers who've spent a lifetime watching the sea's behavior, have noticed it too. Even if they didn't have the language for what they were seeing, they might say the fish come more in one place than another, or that certain patches of reef never die back, no matter how warm the water gets. These are the kind of observations that don't show up in data sets, but they live in memory, passed down through practice and trust in what the sea tells you if you're quiet long enough to listen. That's the human part of this, the way we find ourselves drawn into the rhythm of something we can't see but still somehow feel. We test the water, we log the data, we model the flow. But beneath all that, there's a simple truth. The ocean still carries secrets, and among the most profound are the ones that move not with the waves, but deep below, through forgotten channels, shaping life in ways we have yet to fully understand. These hidden waters aren't loud. They don't demand attention, but they carry the memory of the earth, and maybe even a clue or two about our place in it. And once you begin to follow the quiet drift of these hidden waters, you inevitably come to the places where time has left something behind. Silent markers of those who were here long before us, in an age when the sea had not yet swallowed these hollows whole. Because beneath the still blue surface of some of these sinkholes, in the suspended calm where no light reaches and no current stirs the dust, there are remnants of human lives. Bones, tools, fragments of ritual carefully placed rather than discarded. Things that don't belong to the rhythm of the ocean, but to the hands that once shaped them and the beliefs they carried with them into the dark. It's a strange feeling, looking at something crafted by a person whose world no longer exists. In the cenotes of the Yucatan or the deep blue holes of the Bahamas, divers have found human remains in positions that suggest not accident, but intention. Burials rather than missteps, offerings rather than losses. In some cases, the skeletons lie far below the waterline, in dry chambers that were only flooded after the ice age ended and sea levels began their long, slow rise. That means someone had to climb down into the earth, navigate narrow passages, bring torches or flame, and lower a body with care into the earth's open mouth. That's not just a practical act. It's a deeply human one. Whether it was grief, ceremony, or a belief in something beyond, it tells you that these places mattered in a way that went beyond survival. Tools have been found too, sometimes made of stone, sometimes shaped from materials that only survive in the protective stillness of the underwater void. A blade placed near a body, a carved figurine left in a crevice, a line of stones arranged with purpose rather than chance. Each of them speaks not just to the presence of people, but to intention, to meaning. And in a way, that's what turns these sinkholes from geological features into sacred space. The people who left these things behind didn't have modern equipment or mapped cave systems. What they had was memory, myth, and a closeness to the land and water that we often forget to keep. There's something humbling about that. You stand at the edge of a blue hole today, with satellite maps and oxygen tanks and high-powered lights. But 1,000 years ago, someone else stood there too, with only the stars and the land and the stories passed down to guide them. And they chose to go down, not to conquer or collect, but to place something sacred into the earth, trusting that it would rest there, undisturbed, for the rest of time. And perhaps it would have, if the water hadn't risen and the world hadn't changed. But now we find these things again. Not because we deserve them, but because the ocean, in its quiet way, has decided we're ready to look. And having unearthed the evidence of those who once ventured into the depths, it becomes necessary to take a step even further back, to imagine not just what was left behind, but the world as it was when these blue holes were not blue at all, when they were open, dry, and part of the living land. Before the seas crept inland, before the shoreline redrew itself over centuries of melting ice and warming skies, these sinkholes yawned from the limestone beneath like quiet wounds in the earth. To the people of that time, they weren't underwater caverns. They were entrances, thresholds, perhaps even places of gathering, fear, or reverence, depending on what they came to mean in the lives they shaped. You can almost picture it. A group of early humans standing at the edge of a vast, silent pit in the ground, the air cooler as it pours upward from the depths. There are no guardrails, no warning signs, just instinct and caution passed down through the tribe. Maybe they used the holes as shelters during storms, or as places to store things where animals wouldn't find them. Maybe the acoustics alone, the way a voice would echo and disappear, spoke to something in them that words couldn't name. The interior of these dry chambers would have been dark, unfamiliar, and difficult to navigate. Yet they went in anyway, guided by flame and memory, by need or belief, or both. In some regions, the dryness of those ancient sinkholes allowed them to preserve more than just objects. They preserved experience. Charcoal remnants near entrances suggest fires were lit, and in some cases, soot stains on ceilings point to torches carried deep into the cavern systems. These weren't quick visits. People explored, sometimes mapped them in their own mental ways, learned their twists and depths, and when they returned they brought stories of a place beneath the world, perhaps sacred, perhaps dangerous, perhaps both. What's striking is not just the interaction, but the persistence of it. Across generations, these places weren't forgotten or passed by. They became something more, woven into the rhythms of early life, tied into seasonal movements, rituals, or perhaps even early concepts of death and the afterlife. What makes this history feel so deeply human is that it wasn't written down. It was lived, felt, and remembered in ways we can't fully reconstruct. But you can sense it in the deliberate placement of things, in the careful steps taken across ancient floors, in the way the dead were lowered with care into the quiet. These weren't people who feared the unknown and fled from it. They entered it, not with recklessness, but with purpose. And though the water has since risen and sealed those spaces in silence, the echoes remain, etched into the stone, resting in the silt, waiting for us not just to find them, but to understand what they meant to those who came long before we ever gave these places names. And once you begin to grasp how those early people may have known these sinkholes as part of their world, places they entered, marked, and perhaps even trusted, you begin to see why there's still so much disagreement, so much tension, around what exactly these blue holes can tell us. The question is not simply whether ancient humans used them, but whether these places can truly preserve the trace of that use in ways we can recognize, interpret, and trust. It's a debate that sits quietly between archaeology and geology, between what time can keep and what it quietly erases. And like many debates rooted in deep time, it doesn't offer easy answers. Some researchers argue that blue holes are among the most promising archives of early human activity, not because they were built for it, but because of what they became once the ocean claimed them. The lack of oxygen at depth, the stillness of the water, the isolation from currents and storms. These factors can create conditions where delicate things survive, where organic material that would rot away on land remains untouched. But others are more cautious, pointing out that water, no matter how calm, still moves, still infiltrates and shifts and carries things with it. They remind us that the very nature of these places, their openness, their complexity, their layered geologies, makes it difficult to say with certainty whether something found is in its original resting place, or if it drifted, fell, or was pushed by water over years or centuries. The preservation is not guaranteed. It is conditional, dependent on depth, temperature, chemistry, and luck. There's also the simple truth that humans are drawn to patterns, even when the patterns aren't truly there. A carved bone can be a tool or a fluke of erosion. A stone arrangement can be the work of hands or the slow consequence of collapse. And so, every new discovery made in the deep recesses of a blue hole comes with questions that are often louder than the find itself. Was it placed with meaning? Was it brought by the sea? Or did it arrive by some accident of time that no longer leaves a clear trail? These questions aren't just scientific, they're emotional. Because to say that these holes can preserve the memory of our ancestors is also to say something about who we are now, and how far back that thread of story really reaches. The people who dive into these spaces today, archaeologists, geologists, explorers, they do more than document. They feel their way forward, balancing curiosity with respect. And sometimes, they surface with more than artifacts. Sometimes they surface with doubt. That, too, is part of the work. Because the truth is, these places do not hand over their answers easily. They are quiet, closed, and dark for a reason. But within that stillness lies the potential for something rare. Not just objects, but context. Not just history, but meaning. And maybe, in the end, it's that possibility, the chance that the past still whispers from beneath the water, that keeps us returning even when the answers slip just out of reach. Part 10. Natural Wonders and Future Risks. There's something strangely humbling about the idea that life, when pressed hard enough by time and pressure, will find a way to keep breathing even in places that seem unfit for it. Along the sheer rims of blue holes, those deep yawning mouths in the ocean floor, life clings to the edges, stubborn and slow and quietly beautiful. It's not dramatic, like a jungle or a coral reef full of color and noise, but more like the last candle still burning in a storm-battered house. Around these rims, coral colonies often form in silence, building themselves up grain by grain, almost like they remember a time when the oceans were more forgiving and the water was kinder. You wouldn't know it by looking down into that darkness, because blue holes have this quiet menace to them. But just along the shallows where the light still touches the limestone, there's a kind of sanctuary being carved out in real time. The deeper water around most reefs today is warming faster than nature knows how to adapt to, and the acidity creeps in like rust, undoing millions of years of slow construction. But along the peripheries of some blue holes, the conditions are just a little bit different. Cooler, shaded, a little more buffered from the chaos outside. It's almost as if these sinkholes act like time capsules, preserving pieces of marine life that have nowhere else left to go. Coral, fish, sometimes entire micro-ecosystems find shelter here, not because the place is rich or welcoming, but because everything else has become so much worse. It's not ideal, but it's possible. And in a time when survival feels like a rare currency in the ocean, possible is sometimes the best you get. You have to imagine the researchers who spend their lives studying these holes. These aren't tourists or thrill seekers. These are people who've seen what climate change has done to the reefs, watched them bleach out, watched them crumble. They don't romanticize the beauty. They see the losses, and they look for the edges where life is still holding on. So when they dive near these blue holes and find coral species hanging in there, or fish that have disappeared from surrounding waters, it's not a miracle. It's a sign. A warning, maybe. A quiet kind of hope, too. These rims might be some of the last places where biodiversity can take a breath, while the rest of the ocean is gasping. But it's a fragile balance, the kind that makes you uncomfortable once you realize how easily it can all tip. Blue holes aren't immune to pollution, or ocean acidification, or the sheer reach of human carelessness. If anything, their isolation makes them more vulnerable to certain kinds of damage. Once something gets in, it tends to stay. And while they may serve as refuges now, they're not fortresses. They're not going to save the ocean. They're just small, deep places where the clock ticks a little slower and where the natural world might be buying itself some time. Whether we do anything useful with that time, well, that part's up to us. And yet, even in those sheltered rims and hidden depths where life holds on with quiet resilience, There's no real escape from what's coming. The surface may seem untouched, still and blue, but beneath it, the story is changing faster than most of us are ready to admit. What's happening in the wider ocean doesn't just stay out there. It creeps inward, seeps down through layers of water like a slow poison, reaching even the places we once thought might be spared. And the truth is, when the ocean's warm, they don't ask for permission. The heat pushes in, altering the delicate balance of oxygen, shifting currents, distorting the ancient rhythm that these blue holes and their inhabitants have relied on for longer than we've been keeping records. You have to remember that the creatures living around these rims aren't built for constant change. They're not made to adapt at the speed we're forcing on them. The temperature shifts throw off spawning patterns, confuse migrations, sometimes silence entire populations before we've even had the chance to name them. And it's not just about the heat. It's the acidity, the kind that wears down coral skeletons from the inside out, like termites in the foundation of a house. It weakens what's already fragile, leaves behind silence where there used to be sound. Some researchers describe it like watching a slow-motion collapse. They go back year after year, and the things they used to count on, the sponges, the tiny crustaceans, the coral polyps, start to disappear one by one. And there's no one dramatic moment where it all falls apart. It just fades. Then there's the part that's hardest to talk about, because it's the one we can control and still get so wrong. Human interference doesn't always come in the form of oil spills or plastic bags drifting in from the shore. Sometimes it's subtle. Poorly planned coastal development, boats dropping anchor in the wrong spot, divers looking for Instagram moments instead of understanding. These are places that evolved in isolation, shaped by stillness and time. We show up with noise, lights, machines, and we think if we're not doing something catastrophic, we're not doing harm. But even minor disruption builds up, like footsteps on an old staircase, weakening something that was never built for constant traffic. The sediment gets stirred up, light penetration changes, delicate organisms get stressed, and stress in the natural world has a cost. Some of the scientists working on this now aren't young anymore. They've been watching this slow unraveling for decades. They don't talk about saving everything. They know that's not how this works. What they talk about is slowing the damage long enough for something to adapt, for something to make it through to whatever comes next. They treat these ecosystems like aging relatives, ones who still have stories to tell. If only we'd sit down and listen. If only we'd stop pushing them toward the edge for one more year of comfort or profit. Because when they go, it won't be with fireworks. It'll be in silence, a little darker, a little emptier, until one day someone looks down into a blue hole and realizes it's no longer a refuge, just a memory. But the real trouble starts long before anything dies off or disappears. It begins with what you can't see. The invisible shifts deep in the water where chemistry and biology have been keeping quiet company for thousands of years. Down in those depths, especially in the layers of blue holes where light barely reaches, the balance of oxygen, the work of microbes, the way elements move and settle, it all runs like a finely tuned machine. But that machine wasn't built for a world where the atmosphere changes faster than the oceans can adjust. And when the balance breaks, it doesn't make a sound. It just stops working the way it used to. Oxygen, for instance, isn't something most people think about when they look at the ocean. But down in the layers of a blue hole, it determines everything. Too much oxygen in the wrong place, and ancient anaerobic microbes, the kind that survive without it, can't function. Too little in the layers where it's needed, and the organisms that rely on it begin to suffocate, slowly and invisibly. Warmer water holds less oxygen to begin with, and as temperatures climb, the whole vertical system inside these holes begins to shift. The layers mix differently. The boundaries between oxygen-rich and oxygen-poor zones start to blur. And once that happens, microbes that have been living in peace for centuries get pushed into chaos. Some die off, some mutate, some take over where they shouldn't. And when those microbial communities start changing, so does everything else. It's strange how much life depends on what these microbes do. They regulate nutrients, break down waste, shape the very chemistry of the water. You don't see them, you don't hear them. But without them, the system collapses like a bridge losing its support beams. These microbes were formed in environments with stable temperatures, stable gradients, specific chemical signatures. But now, with climate change altering ocean chemistry, changing the pH, shifting the carbon balance, releasing metals and sulfides from the sediment. It's like rewriting the rules of a language they've always understood. And they don't adapt quickly. They fall out of sync, or they overreact. Some species that used to stay deep begin to migrate upward. Others vanish completely, leaving behind gaps in the ecosystem that don't get filled. People who study this don't come back from the field with easy answers. They come back with more silence, more uncertainty. And maybe the hardest part is that you can't fix chemistry once it shifts too far. You can't just dump oxygen back into a system and expect it to work again. You can't undo what happens when microbial communities unravel. It's not like rebuilding a forest. You can't see the damage clearly, and by the time you notice it, the system has already rerouted itself in ways that might not include life as we knew it. And for those who've spent their careers trying to understand these processes, not to control them, just to keep pace with them, it feels a little like chasing shadows underwater. Always a few steps behind a change you wish you didn't recognize. And even if we could see it all clearly, even if we knew exactly what was changing and when, there's still the matter of actually doing something about it, which, more often than not, is where the story stumbles. These blue holes, as striking and fascinating as they are, sit in places that most people will never reach, and few can truly study. Some are hidden offshore, deep beneath currents that shift without warning, far from ports or funding or attention. Others lie in protected zones on paper, but in practice, they're simply too remote or too costly to monitor. The people who do get there, marine biologists, cave divers, ocean chemists, don't go casually. It takes permits, money, custom equipment, a whole lot of luck with weather, and sometimes even a certain level of personal risk just to gather data that, more often than not, raises more questions than it answers. That kind of isolation makes conservation a strange battle. You're trying to protect something that most of the world doesn't even know is in danger, let alone exists. There are no crowds lining up to see a blue hole, no national campaigns, no urgent hashtags. What they are is complicated, geologically, chemically, biologically. And complication doesn't trend. That leaves a handful of researchers and local conservationists doing what they can with limited tools, often trying to make the case for urgency in a world that doesn't move unless something burns or bleeds. And because these sinkholes are so inaccessible, the data comes in slow, patchy, sometimes years apart. That means it's hard to measure change in real time, hard to respond when things start tipping, and even harder to convince decision-makers that something is worth protecting when you can't show them a photo that makes them care. And behind all that is the quiet truth that awareness, as obvious as it sounds, is its own kind of lifeline. People don't fight for things they don't understand. They don't fund research into places they've never heard of, and they certainly don't change their habits for ecosystems they've never seen. So while the science continues, deep dives, sample collection, analysis done in quiet labs, the other half of the work is just getting someone to listen. Sometimes it's a school group in a coastal town. Sometimes it's a grant board, or a government panel, or just one more article hoping to break through the noise. And the researchers? They keep going back, keep stitching together what little data they can, hoping it's enough to spot the collapse before it's too late, knowing full well that without the world looking, even the most remarkable places can disappear without a sound. And once that awareness does finally reach the surface, once a blue hole makes its way into a travel magazine or a drone video goes viral, then comes a different kind of threat, the kind that wears a smile and carries a snorkel. It starts slow. A few divers, a few boats, a tour company offering something off the beaten path. But soon enough, the path is beaten, worn down by the weight of interest, and what was once a fragile, hidden system becomes the next big thing to visit before you die. The trouble is, blue holes aren't built for attention. They're not beaches. They're not swimming pools. Their value comes from their stillness, from the fact that very little has disturbed their layers in thousands, sometimes tens of thousands, of years. And every time a fin kicks too hard, or an anchor drags across the rim, that stillness unravels a little more. Most people diving these places don't mean any harm. They're curious. They've seen the photos, read the blogs. Maybe they even understand that what they're looking at is rare. But knowing something is special, and knowing how to move through it without damaging it, those are two different kinds of understanding. In many of these sinkholes, The upper sediment layers are like pages in a history book written in silt and shell, laid down one on top of the other over millennia. One careless movement, one hand on a wall, one fin too close to the floor. And that record is disturbed, scattered into the water like ash in the wind. Once it's gone, you can't put it back. You can't unmix what was settled. Then, there's the matter of cumulative impact. One diver might cause no damage, 10 might only leave a few traces. But scale that up over a season, over a few years, and the very act of visitation becomes the thing that undoes the mystery. The turbidity increases. Algae starts to bloom in places it never did before. The clarity fades. Fish that relied on undisturbed light patterns or shelter retreat or disappear. Researchers return and find their instruments giving inconsistent readings, their comparisons disrupted, their timelines blurred. What they came to study has already changed, and not from climate or time, but from people simply wanting to see it for themselves. And the problem, as always, is that regulation tends to arrive late, after the damage has started. These are not places with staff at the gate or fences to keep folks back. Often they lie in international waters, or in countries with other pressing concerns. So, unless there's a concerted effort to set boundaries early, limits on how many can visit, rules for how they move, guidelines for what equipment can touch the water, then the blue holes risk becoming another example of our inability to leave anything truly wild. You hear divers sometimes say they want to experience these places before they're gone, not realizing that in chasing that moment, they might be speeding up the disappearance. And that's the heart of the tragedy, when love for something rare becomes the reason it can't stay rare for long. We've always looked up, toward stars, toward planets, toward the quiet vacuum of space, searching for what lies beyond. But sometimes, in our longing to stretch outward, we forget that mystery still lives right beneath our feet, or just below the surface of the ocean. Blue holes, deep and shadowed, are the kinds of places that remind us of this. They are not just geological oddities or scientific puzzles. They are reminders that Earth is still a frontier, still unknown in ways that can startle us. Descending into a blue hole is not unlike stepping back in time, or falling into another world where familiar rules no longer apply. Within their sunless chambers, we find ecosystems sealed off from the rest of the planet, harboring life that evolved in isolation, untouched by surface change. Some are toxic, some oxygenless, some host ancient bacteria that could rewrite what we think we know about life itself. And yet many remain almost entirely unexplored. There's a strange humility in realizing how much we still don't know about our own world. We map galaxies with better resolution than we map the seafloor. We dream about colonizing Mars, while entire species live and die in hidden marine caverns no one has ever laid eyes on. Exploration, real exploration, the kind that asks something of us, doesn't always mean leaving Earth. Sometimes it means confronting the parts of our planet that still resist being known. These are not glamorous places. There's no sweeping Martian horizon, no flag to plant. But there is meaning in the descent. There is a quiet bravery in choosing to descend into darkness, into danger, into places where the weight of the unknown presses in from every side. The impulse to explore is not a mistake. It's part of what makes us human. But it's worth asking whether we've mistaken direction for depth. It's easier to point a telescope skyward than it is to sink beneath 100 meters of black, collapsing water. But if we want to understand what life can be, how fragile it is, how resilient, how strange, then we have to be willing to look inward before we look outward. The blue holes won't wait for us. Time has already made them archives of Earth's forgotten past. If we ignore them, those chapters may never be read. And maybe one day, when we do step onto another world, what we've learned from the silent places of this one will help us understand it just a little better. Maybe we'll be better listeners, better caretakers. Because sometimes the most profound lessons about the universe aren't written in the stars, but buried in the cold, dark water beneath our own sky. And as we sit with that thought, that perhaps the most humbling truths lie within the depths we've long ignored, we come to realize something even more unsettling. Blue holes don't just beckon us to explore, they force us to reconsider the very foundations of what we think life needs to exist. In the stillness of these submerged chasms, where sunlight cannot reach and oxygen vanishes, where poison lingers and temperatures remain constant and cold. Life doesn't merely survive. It adapts, flourishes, rewrites its own rules. It's one thing to observe resilience in the usual places, in the forests or the coral reefs. But when life shows up in a place where every condition should scream, no, it makes you wonder how many of your assumptions are nothing more than guesses dressed up as certainty. There's something deeply personal in that. We grow up learning a narrow definition of survival: breathe air, need light, require warmth, and we build entire systems of thought around what's possible and what isn't. Then you look into one of these deep blue wells of silence, and you find bacteria that don't need oxygen, or entire microbial networks built on chemical exchanges we once thought could only occur in controlled laboratories. It shakes something loose inside. It reminds you that isolation doesn't always mean emptiness, that harshness doesn't always mean lifelessness, that sometimes, in the most unlikely pockets of existence, life figures out a way to write a different kind of story. And maybe that's what stirs the most, the way these places whisper truths about ourselves, about how we view loneliness, how we define the boundaries of possibility. We think of isolation as a kind of death sentence, cut off, forgotten, left to silence. But in the blue holes, that silence holds life that's been evolving quietly for thousands, maybe millions of years, away from the noise, away from the light, untouched by any need to be understood. And perhaps that's what makes these places so important. They remind us that the world is bigger than our narratives, that survival is not always loud or proud or visible. Sometimes it is quiet, patient, and hidden in places we're too afraid or too busy to look. And in that realization, there's something not just scientific, but deeply human. Something that invites us to let go of our need for certainty and instead to listen, to let the unknown teach us. And once you've sat with that discomfort, the unsettling notion that life rewrites itself in silence, in darkness, you begin to see that blue holes are not simply places where strange life survives. They are something far older, far more patient than that. They are living records, not carved in stone or ink, but preserved in layers of silt, in trapped pockets of ancient water, in chemical signatures unchanged for millennia. They hold the Earth's breath from a time before we had language to name it. And that makes them more than scientific footnotes. They are memory, suspended in stillness. There's a reverence that grows the longer you consider it. In a world that moves so fast, where everything is updated, upgraded, and forgotten again, here lie vaults of time untouched by the surface world. They carry the scent of epochs we never witnessed, traces of ancient atmospheres, evidence of long-dead oceans, whispers of microbial life forms that once filled the sea before complex creatures even had spines. And in a way, that kind of preservation is deeply human in its meaning. We bury things when we want them remembered. Photographs, letters, time capsules. But nature, without intention, has been keeping her own archive. And blue holes may be among the few places left where those pages haven't been scattered by wind or washed away by tide. So it's not just curiosity that draws us down into them. It's the chance to listen to the Earth speak in a voice she's used since before we arrived. Every layer of sediment, every trapped gas bubble, every isolated microbe is a word in that long sentence. And maybe part of our role, our privilege, is to read it with the kind of attention it deserves. Not just because of what we might discover, but because of what it reminds us. That we are recent guests on this planet. That the world has been keeping her story long before we had ears to hear it. And if we're quiet enough, respectful enough, we might still have time to learn from it. And after you've stood at the edge of that realization, that these silent chambers beneath the sea are holding the planet's memory, untouched and unspoiled, you begin to feel a kind of shift. Not a scientific one, but something more intimate, more difficult to name. Because it's one thing to study life in the light, where everything is visible and warm and familiar. But once you know that life can begin and persist in the dark, in places where pressure crushes, where poison fills the water, where warmth and sunlight never reach, it changes how you see the rest of the universe. The darkness no longer feels so empty. It no longer feels so final. And that thought, small, quiet, and hard to let go, follows you upward, even as you leave the deep behind. If life can make a home in the depths of these forgotten holes, cut off from everything we think is necessary. Then maybe we've been looking at the cosmos the wrong way around. Maybe the question isn't whether life exists out there, but how many kinds of darkness we haven't yet learned to look into properly. Maybe what we call lifeless is just misunderstood, or still sleeping, or speaking in a chemical tongue we haven't learned to translate. So you carry that with you, that gentle reckoning. Because when you know that life can rise in total blackness, in silence, in isolation, you start to wonder about all the other places we've dismissed. Icy moons, buried oceans, drifting comets, even the shadowed folds of interstellar space, not just as cold, dead things, but as waiting places, as questions, as possible homes. And maybe that's what blue holes truly offer us in the end. Not just knowledge, but a shift in perspective, a deeper patience, a longer view. Because if the Earth hides such stories in its darkest corners, then the stars might too.